Hey, champs of exams. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to study the entrance exam question papers. This one and similar type of many more exam papers are also available there. For a better preparation, you must download our app. The link is available in the description box. So let's start with question number 1 today for the paper AP EAPCET 17 May 2023, Shift 1. I'll be solving the mathematical part of the paper. You know, there are physics and chemistry sections as well. And for those ones, also do explore our website because you have the video solutions for those as well. So, a very best of luck. We shall start with the question number 1 for the paper. Here we go. If a set A has n elements, then the number of functions defined from A to A that are not 1 is. See, the number of functions that can be defined from a set into another set can be n raised to power n. And the number of functions that are 1, let's write it clearly. Number of functions that can be defined from a set into another set is given by n raised to power n, and the number of functions that are 1, number of functions that are 1 is given by n factorial. So hence the number of functions defined from A to A that are not 1 is n raised to power n minus n factorial. That makes option C to be the answer. Hope you understood this. Let's move to the next question. Question number 2, if fx is a signum function, then in terms of fx, the constant function gx is equal to 1 for all x belonging to R is. Okay, so here you have fx is the signum function. So that means this is equal to -1 for x less than 0. This is equal to 0 for x is equal to 0. And this is equal to 1 for x is greater than 1. And you are given that g of x is equal to 1 for all x belonging to R. So, okay. And for x is less than 0, because for that for that fx is equal to -1. And for x is equal to 0, because sorry, one thing I forgot to mention, for x is less than 0, for because fx is -1, the gx will be given by 1 is equal to 1 plus -1 plus 2, which is equal to fx plus 2. And for x is equal to 0, gx is equal to 1 is equal to 1 plus 0 is equal to 1 plus f of x. And for x is greater than 0, gx is equal to 1 is equal to fx. So here gx is equal to, it's having fx plus 2 for x less than 0, and this is equal to 1 plus fx for x equal to 0, and this is equal to fx for x greater than 0. So that makes this option D to be the answer. Hope you understood this. Let's move to the next question. Question number 3. If A is given by this matrix, then what is the value of A plus A cube plus A power 4, A power 5 plus 3i? So you have to find out all of these. You already know what A is. Let's go for A squared. This is equal to 1, 1, 3, 5, 2, 6 minus 2 minus 1 minus 3 into 1, 1, 3, 5, 2, 6 minus 2 minus 1 minus 3. So, first row into first column. So you have this will be on solving like first row multiplied by first column. This will give me 1 plus 5 minus 6. And then you have 1 plus 2 minus 3. Then 3 plus 6 minus 9. Okay. Then you have second row, first column. This will be 5 plus 10 minus 12. And this will be 5 plus 4 minus 6, 15 minus 12 minus 18. Then third row, first column, second column, and third column. This was minus 2. So minus 2 minus 5 plus 6 minus 2 minus 2 plus 3. And yeah, then you have minus 6 plus 9. This will make the matrix as a 1, 0, 0, 0, 3, 3, 9, minus 1, and minus 3. So now a cube will be given by a square into a matrix. You already know how to multiply. So this is equal to 0, 0, 0, 3, 3, 9, minus 1, minus 1, minus 3. This thing multiplied by 1, 1, 1, 5, 2, 6, minus 2, minus 1, minus 3. This on solving will give you a null matrix. When you will solve, you will get a null matrix. So a power 4 will be a power 5. This will also be because a power 4 is nothing but this is a power 3 into a square. So anything multiplied by null matrix will give me a null matrix. And also a power 5 is equal to a power 3 into a power 2, which will also be here because a power 3 is a null matrix. So a power 5 will also be a null matrix. Now you have to find out, you already know 3i is given by 3 into 1, 1, 1, 0, 0, 0, 0, 0, 0. So this is equal to 3, 0, 0, 0, 3, 0, 0, 0, 3. All right. So what you had to find out was a plus a cube, a power 4, a power 5, 3i. So this is 1, 1, 3, 5, 2, 6, minus 2, minus 1, minus 3, plus null matrix because a power 4 and 5, they are this, and this, they all are null. So I'm not going to write them. This is 0, 3, 0, 0, 0, 3, 0, 0, 0, 3, which will be equal to 4, 1, 3, 5, 5, 6, minus 2, minus 1, and 0. So let's check with the options, which is the correct one. Here you have option B as the answer. Hope you understood this. Let's move to the next question. Question number 4 is the solution for the system of these 1, 2, and 3. These equation is alpha, beta, gamma. Then what is the value for alpha squared plus beta squared plus gamma squared? So these are the three equations. Let's say this is 1, 2, and 3. On adding 1 and 3, adding 1 and 3, we get 3x plus 2z is equal to 5. Now multiplying equation 2 by 2, multiply equation 2 by 2 and adding 1 and 2 equations. Let's say this is number 4. What you will get 7x plus 3z is equal to 5. Let's say this is equation 5. Now comparing 4 and 5. You have 7x plus 3z is equal to 3x plus 2z, or 4x is equal to minus z, or x upon z is equal to minus 1 by 4. Here you have x is equal to minus 1 and z is equal to 4. Now by using equation 1, you have minus 1 plus 2y minus 4 is equal to 3. 2y is equal to 8, or y is equal to 4. So your x, y, z here refers to your alpha, beta, gamma, and this was equal to, x came out to be minus 1, 4, and 4. This is equal to alpha, beta, gamma. And you had to find out was alpha square, beta square plus gamma square. So this is 1 plus 4 square plus 4, 1 minus 1 square rather, plus 4 square, which is equal to 33. So this is the answer, 33, option A. Hope you understood this. Let's move to the next question. Next is 5 is a matrix problem. So if this matrix multiply this is equal to 0, you have to find out the value of x. So you know the multiplicative rule for matrices, the number of columns of the first matrix should be equal to the number of rows of the second matrix. So this is the first one is a matrix, 1 rows, 3 columns, and this is a 3 by 3 matrix. This is 3 by 1 matrix. So here the number of columns and number of rows, they are equal. So that means they are multiplicable. This will give me x into 2, so 2x plus 4, x minus 2, 8 minus 4, this is a matrix, and here is this. Now this is equal to 0. And now let's multiply this again. Now this matrix is 1 row, 3 columns, and this is 3 rows, 1 column. Now let's multiply this again. You will have a 2, or you will have x into 2x plus 4 plus 4 into x minus 2 minus 1 into 4. This is equal to 0, or this gives you 2x square plus 4x plus 4x minus 8 minus 4. So, okay, minus 4, this is equal to 0, or you have 2x square plus 8x minus 12 is equal to 0. X squared plus 4x minus 6 is equal to 0. Let's apply the quadratic formula to solve. So this is minus 4 plus minus root of 4 square minus 4 into 1 into minus 6 whole divided by 2 into 1. So minus 4 plus minus root of this thing holding divided by 2. You have minus 2 plus minus this way, this is root of 40. Yes, root of 40. So this is I'm taking it to outside. Wait. Okay, so this is this is minus 2 plus minus root 10. This is the answer, x value, and you have option C as the correct answer. Hope you understood. Next is question number 6. For real numbers a and b, if 4a plus iota 3a minus b is equal to this, and z is given by a plus b upon 4, then what is the modulus of z upon a? Yeah, uh, z is being talked about a complex number, so probably this will be iota b by 4. All right, now let's start with the question. You are having 4a plus iota 3a minus b is equal to b minus 6 iota. Now comparing the real and the imaginary numbers, you have 4a is equal to b, or 3a minus b is equal to minus 6. With this value in this equation, you have 3a minus 4b is equal to minus 6, or b will be equal to 6. And correspondingly, if b is equal to 6, then 4a is equal to 6. That gives me a is equal to, wait, that gives me a is equal to 3 by 2. Question number 6, for real numbers a and b, if 4a plus iota 3a minus b is equal to b minus 6 iota, and z is equal to a plus b upon 4. Since it's talked about a complex number, so probably this is iota b by 4. Then what is the magnitude or modulus of z upon a? Okay. So here is, first of all, you are having 4a plus iota 3a minus b is equal to b minus 6 iota. Now comparing the real and the imaginary parts. You have 4a is equal to b, and you have 3a minus b is equal to minus 6, or 3a minus 4a is equal to minus 6, which gives me a is equal to 6. If a is equal to 6, then you have b is equal to 4a, or 24. I got the value for a and b. Now what is this complex number z become? This is equal to a plus b upon 4 iota. So this makes the complex number to be 6 plus 24 upon 4, 6 iota. This is the complex number. What is the magnitude of it? This is root of 6 square plus 6 square, which is equal to 6 root 2. And to find was this. So this is 6 root 2 upon a was 6. So root 2 is the answer to the question. Hope you understood that. Next, that's option C as the answer. Right. Next is question number 7. So if z is equal to 1 minus iota whole cube into x plus iota, it's purely imaginary number for x is equal to x1, and z is purely real number for x is equal to x2. Then what is the product of x1 and x2? So here you have z is equal to this, right? Let's open it up. So you're having this will be 1 minus this. So this is 1 cube minus iota cube minus 3 into 1 into iota into 1 minus iota into x plus iota, right? Yeah, bracket should come over here. Okay, so now this is, iota cube is equal to minus iota itself. So this will be equal to 1 plus iota minus 3 iota into 1 minus iota, whole thing multiplied by x plus iota, or this will give you 1 plus iota minus 3 iota plus 3, because iota square is equal to minus 1, minus 3, right? Not plus 3. This will be minus 3. So this multiplied by x plus iota, or here you have minus 2 iota into x plus iota. Now I'm going to multiply both of them again. So taking first of all minus 2 outside, I have 1 plus iota into x plus iota. This will be minus 2 x plus iota plus x into iota plus iota square, which makes it minus 2 into x minus 1 plus 1 plus x iota. Okay, now you are given in the question that this z, this was z. Now you are given that z is purely imaginary for x is equal to x1. So that means for x is equal to, if I'm putting x is equal to x1, z is purely imaginary, which means this thing, the real part, therefore the real part will be 0. What is the real part? Minus 2 into x minus 1. This is equal to 0. This gives me x is equal to 1. Sorry, x1. Because for x is equal to x1, this is purely imaginary. Also, you are given that z is purely real for x is equal to x2. So, therefore, the imaginary part will be 0 in this case. Imaginary part will be equal to 0, or minus 2 into 1 plus x will be equal to 0, or you will have x2, sorry. Yeah, you will have x2 as minus 1. You got the value for x1 and x2. x1 was equal to 1 and x2 was equal to minus 1. So the product of x1 and x2 will be equal to minus 1. This is the answer, and the option A is the correct answer. Hope you got that. Next is question number 8. If 1 omega omega square get the cube roots of unity, k is the positive integer, and this plus this is equal to this whole expression, then what is the value of k? Okay. So first, these three are cube roots of unity. So you know one thing, that 1 plus omega square is equal to 0. Let's say number 1, and omega cube is equal to 1. You know this thing. So you are given in the question 1 minus omega plus omega square raised to power 3k plus 1 minus omega. Here was omega. Okay. 1 minus omega square plus omega raised to power 3k. This is equal to okay, this is equal to 1 minus omega plus omega square raised to power 3k plus 1. There is so it's something like this. Okay, I'm writing it properly over here. Here are some misprints. So 1 minus omega plus omega square raised to power 3 plus k plus 1 plus omega minus omega square raised to power 3k plus 1. This gives me 1 plus omega square minus omega raised to power 3k. 1 plus omega minus omega square raised to power 3k is equal to 1 plus omega square minus omega raised to power 3k plus 1. 1 plus omega minus omega square raised to power uh, 3k plus 1. Now, by using equation 1, this can be written as minus 2 omega raised to power 3k minus 2 omega square raised to power 3k is equal to minus 2 omega raised to power 3k plus 1 minus 2 omega square raised to power 3k plus 1. Okay, so this is minus 2 omega raised to power 3k minus of minus 2 omega raised to power 3k plus 1. So I'm bringing this thing on the left hand side, right? So this is equal to minus 2 omega square raised to power 3k plus 1 minus minus 2 omega square raised to power 3k, and I have brought this on the right hand side. Okay, hope you're clear till here. So now this becomes minus 2 omega raised to power 3k minus 2 omega raised to power 3k into omega raised into, I'll rewrite this line. So now this can be written, this line can be written as minus 2 raised to power 3k into omega raised to power 3k minus of minus 2 raised to power 3k plus 1 into omega raised to power 3k plus 1. This is equal to minus 2 raised to power 3k plus 1 into omega square raised to power 3k plus 1 minus minus 2 3k into omega square raised to power 3k. So here I'm taking minus omega raised to power 3k. Here will be 1 minus minus 2 into omega. This is equal to minus 2 omega square raised to power 3k and minus 2 omega square minus 1. You know omega cube is equal to 1, so I'm going to use it over here. This will be minus 2 into omega raised to power 3k, which can be written as 1. So this is 1 plus 2 omega. This is raised to power 3k, and similarly minus 2 raised to power 3k. This is omega square raised to power 3k, which is again equal to 1. So minus 1 minus 2 omega square. I'm going to write it properly. This will be minus 2 raised to power 3k, 1 plus 2 omega is equal to minus 2 raised to power 3k minus 1 minus 2 omega square. So these two things will cancel, and 1 plus 2 omega is equal to minus 1 minus 2 omega square, or you have 2 plus 2 omega plus 2 omega square is equal to 0, or you have 2 1 plus omega square is equal to 0, or 1 plus omega square is equal to 0. Now, this is true for all the natural numbers. You know, this is the identity. Therefore, k can be any number, or k can be any natural number. Okay, so that makes option A to be the answer. Hope you understood. Next, question number 9. Alpha and beta are the two real roots of the fourth roots of unity. And this gamma and delta are the other two roots of it. Then the sum of the eccentricities of the conics z minus alpha plus z minus beta is equal to 4. And this is equal to 6 is. So, okay. Fourth root of unity, that means x raised to power is equal to 4, or x raised to power 4 minus 1 is equal to 0. This gives you x square minus 1 into x squared plus 1 is equal to 0. And spreading it further, you have x minus 1 into x plus 1 into x squared plus 1 is equal to 0. Here you have the values x is equal to 1, minus 1, and iota and minus iota. These are the four roots. Now let's say alpha and beta, they are 1 and minus 1. Delta and gamma and delta, they are iota and minus iota. Then you had z minus alpha plus z minus beta. This is equal to 4 in the question. Right, so that makes z minus 1 plus z plus 1 is equal to 4. It represents an ellipse with the focus 1, 0. It represents an ellipse with focus 1, 0 and minus 1, 0, and 2a is equal to 4. Also, 2ae1 is equal to distance between both focus. So 2ae1 is equal to 2, or 4e1 is equal to 2, or e1 is equal to 1 by 2. Similarly, for the second one, z minus gamma plus z minus delta is equal to 6, or you have z minus iota plus z plus iota is equal to 6. Now here, focus are this, we already 0 comma 1 and 0 comma minus 1. 2b is equal to 6, which, and 2b e2 is equal to 2. So 6e2 is equal to 2, or you have e2 is equal to 1 by 3. Right, you have to find out e1 plus e2. That's 1 by 2 plus 1 by 3, which is 5 by 6. So this is the answer to the question 5 by 6, option A. Hope you understood. Next is question number 10. The set x belongs to real numbers such that 16 into 2 raised to power x is greater than 16 raised to power minus 1 by x is equal to. Okay, so 2 raised to 16 can be written as 2 raised to power 4 into 2 raised to power 8 is greater than 2 raised to power 4 raised to power minus 1 by x. This makes it 2 raised to power, bases are same, powers will add, 2 raised to power x plus 4 is greater than 1 upon 2 raised to power 4 upon x. Or you have 2 raised to power x plus 4. Here it will be multiplied, so it will be added. Okay, I'm taking cross multiplication, so it will be added again. So 2 raised to power x plus 4 plus x 4 upon x is greater than 1, which can be written as 2 raised to power 0. That makes x plus 4 plus 4 upon x is greater than 0. Taking the LCM, you have x square 4x. 4 is greater than 0 upon x, because I have taken and multiplied. So this is x plus 2 whole square. Let's write it. Is greater than 0. So see, this thing x plus 2 whole square, this is always positive, right? So if this is always positive, so this thing to be greater than 0, that means x is always greater than 0. Hence, x will belong to a real number such that x is greater than 0. That makes option A to be the correct answer. Right? Next is question number 11. The set x belongs to real numbers such that 4 plus 11x minus 3x square is greater than 0 is the interval. Which of these options? So you have x belonging to real numbers such that 4 plus 11x minus 3x square greater than 0, or minus 3x square plus 11x plus 4 greater than 0. So I want to split the middle term. This will be minus 3x square plus 12x minus x plus 4 greater than 0, and minus 3x, x minus 4 minus 1, x minus 4 greater than 0. So the two factors, this and this, they should be greater than 0. Now, when x is less than minus 1 by 3, x minus 4 is less than 0, and minus 3 minus x will be less than 0. So x minus 4 into minus 3 minus 1 is less than 0. Therefore, the required interval, see over here, if I'm drawing it on the number line, this is infinity to minus infinity. And here is you have 1 by 3, and here you have 4, negative, negative, positive. So the required interval is x belongs to -1/3 to 4. Okay, so that makes option A to be our answer. Right? Hope you understood. Next is question number 12. If the sum of cube roots of this equation is 0, then what is the value of a square a cube plus 3c? Let's write down the equation. You have x cube minus ax square plus bx minus c is equal to 0. Let alpha, beta, gamma be the roots. Okay. Then you know sum of the roots is minus of minus a upon 1. That is equal to a, and sum of product of the two roots, this is equal to b, and the product of the three roots, this is equal to minus of minus c upon 1, that is c. Now alpha plus beta plus gamma square is equal to this plus 2 into alpha beta, beta gamma, and alpha gamma. So what was the sum of the roots? It was a. Yeah. So a square is equal to alpha square, beta square, gamma square plus 2. This was equal to b. So a square minus 2b is equal to alpha square, beta square plus gamma square. And if I talk about their cubes, alpha cube, beta cube, gamma cube minus 3 alpha, beta, gamma is equal to alpha plus beta plus gamma into alpha square, beta square plus gamma square minus alpha, beta plus beta, gamma plus alpha, gamma. Right. So let's fill in the values. You have this alpha, beta, gamma, that is C. And alpha plus beta plus gamma, that's A. And we just solved, this was equal to a square minus 2b minus, and this was equal to b. So you have alpha cube, beta cube plus gamma cube is equal to a cube minus 3ab minus 3 plus 3c. Okay. Now according to the question, a square, a cube, a cube minus 3ab plus 3c. This is equal to 0. That makes a cube plus 3c is equal to 3ab, right? Because the sum of the cube roots of this equation is 0. So that means according to the question, this was equal to 0. That makes a cube plus 3c is equal to 3ab. That is option D. Hope you understood this. Let's move to the next question then. Question number 13, alpha, beta, gamma are the roots for this equation. Then what is summation beta plus gamma upon alpha square? Okay. So in the question, let's write down this first x cube plus 2x plus 5 is equal to 0. And alpha, beta, gamma, they are the roots for the equation. That means first thing, the sum of the roots minus the coefficient of x upon the coefficient of x cube. So this is minus 2. And the sum of, okay, the sum of the this roots is this, and also the product of the roots is given by 5 upon 1. So that is minus 5 upon 1. So that is minus 5, right? Number 13, if alpha, beta, gamma are the roots for this equation, then what is the value for summation beta plus gamma upon alpha square? So you are given the equation as x cube plus 0 into x square plus 2x plus 5. So let alpha, beta, not let, actually it's given to you. So you're given alpha, beta, gamma are the roots. So that means the sum of the roots is is coefficient of x square upon the coefficient of x cube. This is equal to 0. That gives me beta plus gamma is equal to minus alpha. Also alpha, beta plus beta, gamma plus alpha, gamma. This is equal to 2 upon 1. and the product of the three roots is equal to minus 5 upon 1. Okay, now you have to find out summation beta plus gamma upon alpha square. So, beta plus gamma, that was equal to minus alpha. So, summation minus alpha upon alpha square. So, basically, you have to find out summation minus 1 upon alpha. And this is equal to minus 1 upon alpha plus 1 upon beta plus 1 upon gamma, because the summation minus 1 upon alpha is equal to this. So further, let's take the LCM, alpha, beta, gamma minus outside. Here you have beta gamma plus alpha gamma plus alpha beta. So then putting the values, you have everything. You have these values. This is 2 and this is minus 5. So this will give me minus 2 upon minus 5. So this is 2 by 5. This is the answer to the question. Option C is the correct answer. Hope you got that. Next is 14th question. The numerically greatest term in the expansion of this when x is equal to 1 is P1, alpha P2, beta P3, gamma, Y. This should be gamma. Gamma P4 and P1 is less than P2 is less than P4. They are the first four prime numbers. Then what is the value for alpha plus beta plus gamma? Okay, so let's understand the problem once again. Numerically greatest term in the expansion of this when x is equal to 1. So first of all, let's expand this. 2 minus 3x raised to power 9. Numerically greatest term will be T5 or T6. So T5, this is given by 9c4 to power 5 into minus 3x raised to power 4. And T6, 9c5 to power 4 minus 3x raised to power 5. Now you know that 9c4, that's equal to 9c5. And 3 raised to power 5 into 2 raised to power 4 is greater than 2 raised to power 5 into 3 raised to power 4. So numerically greatest term amongst both is, sorry. Question number 14, if the numerical greatest term in the expansion of 2 minus 3x raised to power 9 when x is equal to 1 is given by this, where P1 is less than P2 is less than P3 is less than P4 are the first four prime numbers. Then what is the value for alpha plus beta plus gamma plus delta? Okay, so you are given the expression 2 minus 3x raised to power 9. Numerically greatest term in this will be T5 or T6. They will be numerically greatest terms. So what is T5? This is given by 9c4 to power 5 minus 3x raised to power 4. And T6 is given by 9c5 to power 4 minus 3x raised to power 5. Now you know 9c4 is equal to 9c5 and 3 power 4 into 2 power, 3 power 5 into 2 to the power 4 is greater than 2 power 5 into 3 power 4. Therefore, numerically greatest term will be T6, which is 9c5 to power 4 into minus 3 power 5. Minus 3x power 5. So this is equal to 9 into 8, 7, 6, 4, 3, 2, 1, 2 power 4 minus this into this. So this is equal to minus 2 power 5, 3 power 7. Sorry, minus is outside, not here. 2 power 5, 3 power 7, 7 power 1, x power 5. Right. Here the numerical value is equal to 2 power 5, 3 power 7, 5 power 0, and 7 power 1. So P1 is 2, P2 is 3, P3 is 5, P4 is 7. And according to the question, this is, see, look at this one. So here, this is powers, alpha, beta, gamma, and delta. So what is the power for this? Alpha is equal to 5. Here, beta is equal to 7. Gamma is equal to 0. And delta is equal to 1. You have to find out alpha plus beta plus gamma plus delta. So 5 plus 7 plus 0 plus 1 is equal to 30. This makes option A to be the correct answer. Hope you understood this. Next is 15th question. The number of all 8-digit odd numbers is, okay, it's going to be pretty one, the number of all 8-digit odd numbers. See, what is the smallest 8-digit odd number? That is given by 1, 2, 3, 4, 5, 6, 7, and 8. This is the smallest 8-digit odd number, and the greatest 8-digit odd number is given by 1, 2, 3, 4, 5, 6, 7, 8, 8. Okay. Now, it will be forming an AP with a common difference of 2 for of course, where the starting term will be this, and the next one will be this. So on till the last one will be this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Right. So here the first term is this. Common difference is 2. So nth term is given by a plus n minus 1 into d. So this is 9, 9, 9, 9, 6, 7, 8 is equal to this plus n minus 1 into 2. So I'm subtracting both of them. This will give me 8, 9, 9, 9, 9, 9, 9, and 8. Okay, now this is divided by 2. Yeah, this is divided by 2. This will give me is equal to n minus 1. This on division will give me 4, 4, 9, 9, 9, 9, 9, 9. Yeah. This is equal to n minus 1. So n will be equal to, I'm adding 1 to it. This will be 45, like 1, 2, 3, 4, 5, 6. 45, having the 6 zeros. So this is equal to 45 into 10 power 6. And the number of odd, 8-digit odd numbers is 45 into 10 power 6. Option A. Right. Next is question number 16. The degree of this polynomial is. So you are given the polynomial as x plus root of x power 4 minus 1 raised to power 9 plus x minus root of x power 4 minus 1 power 9. This power will increase when the power of this will increase. See, here the power will increase when power of root x power 4 minus 1 will increase. Okay, so the highest power of x plus root of x power 4 minus 1 raised to power 9 is equal to 9c0 x power 0 x power 4 minus 1 raised to power 9. This is equal to, like, this is 1, this is 1, this is root of x raised to power 4 minus 1 raised to power 9. And the highest power of x minus this thing is given by 9c0 minus 9c0 x power 0 into root of x power 4 minus 1 raised to power 9, or this is equal to minus root of x power 4 minus 1 raised to power 9. Now both terms, see, this is positive and this is negative. 1 and 2 both will cancel each other, right? So that means what will be the highest power? So highest power will be 9C0 into x raised to power 1 into this power 8. This is equal to 9x raised to power 1 into x power 4 minus 1 raised to power 8. So the degree is equal to 1 plus 8 into 4 by 2. That's 17. Okay. That makes here option D to be the correct answer. Hope you got that. Next is question number 17. The number of all 4-digit numbers which begin with 4 and end with a 0 or 5 is. So you want 4-digit numbers that are beginning with 4 and ending with 0 or 5. Correct? So that means the first digit is like this can be filled up in one way for sure. And this one can be filled up in two ways. Correct? So these two middle numbers, they can be middle digits can be filled up in like 10 ways are there, because you are not told anything about the repetition may take place, right? So this can be filled up in 10 ways, and even this can be filled up in 10 ways. So how many possible ways are there? 1 into 10 into 10 into 2, 200 ways. Option A. Right? Next is 18th question. If Fn is n factorial 31 minus n factorial, where n belongs to 0, 1, 2, 3 till 31, then the maximum value of Fn is. So you're given the function Fn as n factorial into 31 minus n factorial. All right. And you're given that n belongs to 0, 1, 2 till 31. Yeah, so that makes f0 as a 0 factorial into 31 factorial. F1 as F1 will be 1 factorial into 30 factorial. F2 will be 2 factorial into 29 factorial. So on F 31, because n can be possible like till 31. So n 31 can be equal to this into 31 factorial into 0 factorial, right? So that means Fn is decreasing as n is increasing. See, as n is increasing, Fn is decreasing. Look over here. This is 31 factorial. This is 30 factorial. This is 29 factorial into 2. So here you see one thing. Fn is decreasing as n is increasing. Therefore, Fn will be minimum. See, this is again 31 into 0 factorial. So that means the middle value will be the minimum one. Will be minimum at n is equal to 15. Because for 31 numbers starting from 0, so from 0 to 31, the middle one is 15th number for sure. Right? So for n is equal to 15, this is having the minimum value, and f of 15 will be equal to 15 factorial into that was 31 minus 15, which is 16 factorial. So 15 factorial into 16 factorial. This is the answer to the question. And you have here option D as the correct answer. Right? Next is question number 19. Tangent A upon 1 minus cot A plus cot A upon 1 minus tangent A is equal to. Okay. I'm starting from here itself. So this I'm like writing cotangent A as this. So this is equal plus cotangent A. I'm letting it like this only for the time being. Cotangent A upon 1 minus tangent A is equal to, this is tangent square A, because I'm taking this on the numerator, upon tangent A minus 1 plus, I'm writing it as like this, tangent A into 1 minus tangent A. Okay, let's take the LCM now. Tangent A into 1 minus tangent A. So this will be minus tangent square A into, actually tangent cube A, right? Because tangent A into tangent A minus tangent cube A, plus 1. Or this can be written as 1 minus tangent A into 1 plus tangent square A plus tangent A whole divided by tangent A into this, right? So this and this will cancel. You will have 1 plus tangent square A plus tangent A upon tangent of A. Let's open it up. You will have 1 upon tangent A plus tangent square A upon this, or this will be tangent A plus 1, right? And that's 1 plus tan A plus, this can be written as cot A. So this is the answer to the question, and here it is, option C is the correct answer. Right, next is 20th question. You have to match the ranges of the functions given in list A with those in list B. So here is list A. Now this is going to be a bit lengthy question because we have to solve here like 4 questions. Okay. First part. This is 3 sine square x, 4 cos square x minus 2. So I'm taking 3 sine square x plus cos square x plus cos square x minus 2. So this is 3 minus 2, because sine square x plus cos square x is equal to 1. So this makes it 1 plus cos square x. You know one thing, that cos square x always lies between 0 and 1. So you have, I'm adding 1 on both sides. This will be 0 plus 1 is less than equal to 1 plus cos square x is less than equal to 1 plus 1, or 1 is less than equal to 1 plus cos square x is less than equal to 2, right? Right. So this function minus 2 belong to 1 comma 2. So here it is, option, right? Okay. Yeah, let's move to the next part now. This is cos square plus sine power 4x. So cos square x sine power 4x. Now maximum value is equal to 1 at x is equal to like 0, pi by 2, pi, and so on. And the minimum value is minimum value at this x is equal to pi by 4, 3 pi by 4, so on. So minimum value is given by, see, for pi by 4, this will be minus 1 by 2, because the cos square pi by 4, this is minus 1, 1 upon root 2 plus whole raised to power 2 plus 1 upon root 2 whole raised to power 4. This is equal to 1 by 2 plus 1 by 4. That's equal to 3 by 4. So this cos square x plus sine power x, x belongs to 3 by 4 comma 1. And let's see, this is here. Okay. Now the third one, sine power 6x, cos power 6x. Sine power 6x plus cos power 6x. This can be written as sine square x plus cos square x into sine power 4x plus cos power 4x minus sine square x cos square x. That's one. into, like, I'm not going to write this one. So this is simply sine power 4x cos power 4x minus sine square x cos square x. So maximum value here is 1 when x belongs to pi by 2, pi, 3 pi by 2, and so on. And the minimum value will be at x is equal to pi by 4, which will be sine sine x, sine pi by 4, this is 1 by root 2 power 4, and this is same for the cos x as well, and minus 1 by root 2 square, 1 by root 2 square. This gives me 1 by 4 plus 1 by 4 minus 1 by 2 into 1 by 2, which is 1 by 4. So the answer is equal to 1 by 4. Hence, sine power 6 plus cos power 6 x belongs to 1 by 4 to 1. So here you have this. This is your third part. Okay. Now let's see the fourth one. Fourth one in the question was, let's read it again. It is cos x into cos 2 pi by 3 plus x. Okay. Cos x into cos 2 pi by 3 plus x cos 2 pi by 3 minus x. Now that's equal to 1 by 2, 2 cos 2 pi by 3 plus x cos 2 pi by 3 minus x. Yeah, into cos x. So this is equal to 1 by 2, 2 cos a cos b. This is cos 2 pi by 3 plus x plus 2 pi by 3 minus x plus cos 2 pi by 3 plus x minus 2 pi by 3 plus x. Whole thing multiplied by cos x. Okay, this and this and this and this will cancel. So you have half of cos 4 pi by 3 plus cos 2x into cos 2x. That's 1 by 2, and this is minus 1 by 2 plus cos 2x cos x. This is minus 1 by 4 cos x plus 1 by 2 cos x cos 2x, or this will be 1 by okay, so I'm writing it like this: 2 cos x cos 2x. This is minus 1 by 4 cos x plus 1 by 4. So this will be cos a plus b. This is 3 plus cos a minus b, which is x. Right. So you have minus 1 by 4 cos x plus 1 by 4 cos 3x plus 1 by 4 cos x. They will cancel out, and this will be 1 by 4 cos 3x. And you know this lies between cos 3x lies between 0 and 1. Sorry, minus 1 and 1. So if I'm multiplying both sides by minus 4, 1 by 4, so this will be minus 1 by 4 is less than equal to 1 by 4 cos 3x is less than equal to 1 by 4. Therefore, cos x cos 2 pi by 3 plus x cos 2 pi by 3 minus x belongs to minus 1 by 4 to 1 by 4. So let's check with the options. Yeah, this is the one. This is the answer. Now let's check with the options which one is the correct one. And one is going with C. One is going with C, 2 with D, 3 A, and 4 B. So yes, we have there option B. This is the correct answer. Right? Hope you understood. Let's move to the next question. ABC, you have to find out the value of this trigonometric function. Okay, so you have sine 2a plus sine 2b plus sine 2c. I'll open up this one first. So this is 2 sine a plus b cos a minus b, 2 sine c cos c. Right? I have solved these two separately and I've opened this one separately. Now, one thing that a plus b plus c was equal to pi. So a plus b is equal to pi minus c. So this makes 2 sine pi minus c plus 2 sine c cos c, or this is 2. Sorry, here I forgot to write cos A minus B plus 2 sine C cos C. So this is 2 sine C cos A minus B, 2 sine C cos C. I'll take 2 sine C common. So inside will be cos A minus B plus cos C, or 2 sine C cos a minus b plus cos c can be written as 180 minus a plus b, right? So this is 2 sine c into cos a minus b minus cos a plus b, right? So this will be 2 sine c, and see, this is cos a minus b minus cos a plus b. This is equal to 2 sine a sine B. So you have 4 sine A sine B into sine C. Now let's pick up your denominator. Cos A plus cos B plus cos C minus 1. Now cos A plus cos B plus cos C minus 1. This can be 2 cos A plus B upon 2. A minus b upon 2 plus, I'm solving this separately now, 1 minus 2 sine squared c by 2 minus 1. So this is equal to 2 cos. Same thing, a plus b plus c is equal to pi by pi. So a plus b is equal to pi minus c divided by 2. So this will be equal to pi by 2 minus c by 2. I'm leaving this as such, cos a minus b upon 2 minus 2 sine square c. I'm writing at like 2 sine c by 2, and 1 sine c by 2 I'm writing as sine pi by 2 minus a plus b upon 2. Okay. So this makes it, this will be 2 sine c by 2 into cos a minus b by 2 minus cos a plus b by 2. Yes, into 2 sine c by 2. Yes. Now I'm going to take 2 sine c by 2 common outside. So here will be cos a minus b by 2 minus cos a plus b by 2. This will be 2 sine c by 2. This is 2 sine, like adding them and subtracting them. This will be the one. So here will be 2 sine a by 2 sine b by 2 and sine c by 2. Therefore, dividing, let's say this is 2 and this was 1. Now dividing 1 and 2. Now, according to the question, which was, what was the question? Sine 2a plus sine 2b plus sine 2c, whole thing divided by cos a, cos b, cos c minus 1 is equal to 4 sine a, sine b, sine c, 4 sine a by 2, sine b by 2 sine c by 2. Okay. So first of all, these now see, this is equal to this. This can be written as a 4 into 2 sine a by 2 cos a by 2. I'm canceling this 4. I'm not going to write this. 2 sine b by 2 cos b by 2. 2 sine c by 2 cos c by 2. Whole thing divided by sine a by 2 sine b by 2 sine c by 2. So these three things will cancel with these three things. Okay. And you will be left with, this will be 8 cos a by 2 cos b by 2 cos c by 2. Okay. So no, one thing that 4 cos a by 2 cos b by 2 cos c by 2, this is equal to sine a plus sine b plus sine c. Here will be 2. Okay. Because 4 cos a by 2 cos b by 2 cos c by 2 is equal to 2 sine is equal to sine A plus sine B plus sine C. Okay, so using this, you have this as the answer, and this is option A. So you have option A as the correct answer. Next is question number 22. Cos 12, cos 24, 36, 48, 72, 84. You have to find the product of them. So let's do one thing. Divide and multiply numerator and denominator by 2 sine 12 degree. So you have to sine 12 degree into cos 12 degree, cos 24, cos 26, 36, cos 48, cos 72, cos 84. Whole thing divided by 2 sine 12 degree. Okay. So yeah, so 2 sine A sine B, this is equal to sine 2A. So this is sine 24, right? Yeah, 2 sine 24 and cos 24. I'm going to again multiply this with 2, numerator and denominator. So here will be 4 sine 12 into cos 36 into cos 48, cos 72, cos 84. Okay. So 2 cos sine A sine B, again this is equal to sine 48 now, because sine 2A, and I'm concatenating it with this sine cos 48 sine 48 into cos 36 cos 72 cos 84, multiplying this numerator and denominator by 2. So here you have this thing. So again, sine A sine B, this will be equal to sine of 96 multiplied by cos 36, 72, and 84 can be written as the cos of 180 minus 96, whole thing divided by 8 sine 12 degree. Okay, so this is, this is equal to sine 96. This is cos 96 into cos 36 into cos 72 degree. Whole thing divided by 8 into sine 12. Okay. Again doing multiply numerator and denominator by 2. So you will have sine 192 degree into cos 36 degree and cos 72 degree. All right. Whole thing divided by 16 sine 12 degree. So now this is sine 192. I can write it as minus sine 180 plus 12 into I'm Doing what? Okay, I'm going to write it over here. So this is equal to minus sine 180 plus 12 and 2 sine 36 cos 36 cos 72, and also I'm dividing the new denominator. First of all, this is 16 sine 12, and I'll be dividing the denominator as well with 2 sine 36 because I have used it over here. Okay, now this is equal to sine 12 itself plus this will be equal to sine 72 degree into cos 72 degree. Sorry, here is multiplication, not the plus. So this is divided by 16 sine 12 into actually 2 sine 36. Okay, so sine 12, and this is equal to, again I'm multiplying this with 2, multiplying numerator and denominator with 2. So this is equal to 144 sine 144 degree. Whole thing divided by, now you have 16 fours are 60, this 64 sine 12 sine 36 degree. So this will be equal to sine 12 can be written as see, sine 12, sine 44. First of all, this sine 12 and sine 12, this will cancel. And sine 144 can be written as sine 180 minus 36 divided by 64 into sine 36, which is equal to sine 36 upon 64 into sine 36. So you have 1 by 64 as the answer. Okay. Option C. This is the correct answer to the question. Hope you understood this. Let's move to the next question now. Next is alpha and beta are acute angles such that sine beta is equal to 2 sine alpha and 3 cos beta is equal to 2 cos alpha. What is secant alpha plus beta? So I'll start from here. You have sine beta is 2 sine alpha squaring both sides. You have sine square beta is equal to 4 sine square alpha. Also, you have 3 cos beta is equal to 2 cos alpha. And again, squaring, you have 9 cos square beta is equal to 4 cos square alpha. So let's say this is equation 1 and 2. Adding 1 and 2, you have a sine square beta plus 9 cos square beta is equal to 4 sine square alpha. I'm taking it common plus cos square alpha, right? And this can be like sine square plus cos square. I'm using 1 cos square from here. This will be 1 plus 8 cos square beta is equal to 4, or 8 cos square beta is equal to 3. That gives me cos beta is equal to root of 3 by 8. Right. Now let's find out cos beta. You had a cos beta as a yeah, sorry, cos beta we already saw. This is root 3 by 8, and from here I'm using this equation to solve. We have 3 cos beta is equal to 2 cos alpha. So 3 into root 3 upon 8 is equal to 2 cos alpha, or you have taking this 3 by 2 into root 3 upon 2 root 2 is equal to cos alpha, or you get cos alpha as 3 by 4 into root 3 by 2. Okay, so this is your value for cos alpha, and now you can this is this is cos alpha. So now let's find out sine alpha. This is root of 1 minus cos square alpha. So alpha is equal to 1 minus cos square alpha will be 1 minus 9 into 3, that is 27 by 16 to the 32. So this becomes a root of 32 minus 27 upon 32, which is equal to root 5 upon 32. So now let's write down first of all what all things we got. We got cos beta, we got cos alpha, we got sine alpha. Now let's solve sine beta as well. That is given by 1 minus, I'm making some boundaries over here. Okay, so sine beta is equal to this 1 minus cos square beta whole under the root. So this is equal to 1 minus 3 by 8, which is equal to root 5 by 8. So this is the value for sine beta. Let's write down all the values that we received. So we had sine alpha as this, cos alpha 3 by 4 into root 3 into root 2, sine beta. Sine beta was, this is root 5 by 8, and cos beta was equal to root 3 by 8. Okay, so now what you had to find out was, cos alpha plus beta. So this is equal to cos alpha into cos beta minus sine alpha into sine beta. Okay, so this is 3 by 4 root 3 upon root 2 into this minus sine alpha is this, and sine beta is this, right? So here you have 3 into 3 into 4 into root of 2 into 4, 16, which will be given by 4 minus root of, I'm taking the root away. So this is root 5 into root 5. This is 5 upon 32 into 8. So this is from here I'm having 2 root 2, and this will be 4 root 2. This will be 8 into 2, 16. Okay. So now this is 9 minus 5 upon 16, or this or this. This was equal to cos alpha plus beta. You had to find out secant alpha plus beta, which is equal to this thing, or this is equal to 4. Okay, so here's your answer. Option A is the correct answer. Hope you understood this. Let's move to the next question. Next is question 24. Sin hx is equal to 5 by 12 and cos hx upon 2 is equal to. So first thing, you know this, that cos h square x minus sin h square x is equal to 1. So you are given this value. So that means this is equal to 1 plus, like I'm squaring it, okay? This will be 25 upon 144 because I'm squaring this and keeping it here, right? So this will be 169 upon 144, or cos h x will be equal to, like, root of this, that is equal to 13 upon 12. Now what you had to find out was cos h x upon 2. So see, this I can write it as 2 cos square h x by 2 minus 1, right? So this was already solved. You had this as 13 by 2. So 13 by 2, I'm taking the one on the left hand side. So you have this thing. Sorry, yeah. Okay, this will be, yes, 15 upon 2 into 2 is equal to, here was x by 2. So 2 cos, sorry, not 2, cos square h x by 2, that is equal to 15 by 4, right? Next is question number 24. If sin hx is equal to 5 by 12, then what is the value of cos hx by 2? Pretty easy question this is. You are having this value and you know one identity that is given by cos square hx minus sin square hx is equal to 1. You are having this value, so you can write down cos square hx minus 5 by 12 square is equal to 1, or this is equal to 1 plus 25 upon 144, or this is equal to 169 upon 144. So you have cos hx is equal to 169 upon 144, which is equal to 13 by 12. Now you have to find out this value cos hx by 2. So for that, I will do cos hx can be written as 2 cos square h x by 2 minus 1, and this was solved to be 13 by 12 plus 1 is equal to 2 cos square hx by 2, or this will be equal to 25 upon 12 into 2 is equal to cos square hx by 2. Root of 25 upon 24 is equal to this thing, right? So this will be equal to 5 upon 2 root 6. So this is the value 5 upon 2 root 6. Option D is the correct answer. Hope you understood this. Next is question number 25. In a triangle ABC, tangent of A by 2 plus tangent of B by 2 into tangent C by 2 is what? In a triangle ABC, tangent A by 2 is given by root of S minus C into root of S minus B upon S into S minus A, whole under the root, and the tangent of B upon 2 is equal to root of S minus C, S minus A upon this thing. Also, tangent C by 2, root of S minus A, S minus B, S minus C. Right, now you have to first of all solve this. So using this, like say this 1, 2, and 3. So I'm adding tangent A by 2 plus tangent B by 2. Tangent A by 2 plus tangent B by 2 is equal to, that is root of S minus B into S minus C upon S into S minus A plus root of S minus A, S minus C upon S of S minus B. Okay. So what I'm going to take common from here is S minus C upon S. So root S minus C upon S, this I'm taking common. Inside will be not equal to. This whole thing I'm going to take common. So inside you will be left with S minus C plus S minus A whole divided by S minus A into S minus B. So this will be S minus C upon S, and you have 2S minus A minus B upon this thing. Okay, now let's multiply this with tangent A, tangent A by 2 plus tangent B by 2 with tangent C by 2. So this was already solved and you had S minus C upon S under the root as common, and inside, see, one thing I would like to talk, that 2S is equal to A plus B plus C. So 2S minus 2S plus C is equal to minus A minus B. Okay, so I'm going to write that thing over here now. Okay, 2S minus, wait. 2S minus A minus B is equal to C. So this thing, I'm going to write as C only. So C upon S minus A into S minus B whole multiplied by S minus A, S minus B divided by S into S minus C. So see, this thing and this will get cancelled. This and this and this will get cancelled. And you will be left with the C upon S. Okay, see, root of S into root of S, this will be S only. So C upon S, right? So now this can be written as A plus B plus C upon 2. S is equal to A plus B plus C upon 2, or this is equal to 2C upon A plus B plus C. So let's check. You have option A as the answer. Hope you understood that. Next is question number 26. In a triangle ABC, if angle C is equal to 90, then what is the product of these two expressions? Okay. So, see, you are having this triangle. Let's say this is ABC. C is 90, right? So this is your 90 degree. This is A and this is B. So this will be C, A and B. So also know one thing, that Pythagoras theorem, A square plus B square is equal to C square. right? R1 is given by delta upon S minus A, R2 is delta S minus B, R3 is delta upon S minus C. Now let's get to our expression. To find was R1 minus R3 upon R1, R2 minus R3 upon R2. So I can write it like this, R3 upon R1, R3 upon R2, or you have this as 1 minus delta upon S minus C whole divided by delta upon S minus A, 1 minus delta upon S minus C, delta upon S minus P. So this is 1 minus S minus A, S minus C. Yeah. 1 minus S minus B, S minus C. Okay. So this is S minus C minus S plus A upon S minus C. S minus C minus S plus B upon S minus C. So here you have this will be A minus C upon S minus C and B minus C upon S minus C. That makes A minus C into B minus C upon S minus C whole square, right? So I think that's it. Okay. Okay, but why I have 1, 3, 4, 2? So that means it need to be solved further. Let's open the brackets. You will have AB minus AC minus BC plus C squared. This was C only. Whole thing divided by S minus C. So this will be, I'm going to write S as A plus B plus C upon 2 minus C whole square. That becomes equal to, I'm keeping the numerator as such for now. So AB minus AC minus BC plus C square, whole thing divided by, this will be A plus B plus C minus 2C upon 2 whole square. AB minus AC plus BC plus C square. I'm taking the 4 in the numerator now. This 4 will be gone in the, this 2 square will be gone in the numerator. So this will be divided by A plus B minus C. Hope this is clear till here. Now, 1 equal to 4AB, AC, BC. Now you know C square is equal to A square plus B square. So I'm going to write it over here, A square plus B square, whole thing divided by, there was a square. Okay, now I'll open up this as well. So A square plus B square plus C square plus 2AB minus 2BC minus 2AC. So this is equal to, I'm going to use some 2's inside. So this will be 2, I'm keeping outside. This will be 2A square, 2B square, 2AB plus 2BC. Wait, here the BC minus, not the plus. So here the BC minus, here is minus and minus 2 AC. Whole divided by A square, B square plus and C square plus B square. I'm changing the C square again as this, plus 2AB minus 2BC minus 2AC. So this is 2A square, 2B square plus 2AB minus 2BC minus 2AC. Whole thing divided by 2A square plus 2B square plus 2AB minus 2BC minus 2AC. Okay, so these two will cancel and you will be having 2 as your answer. That makes option D to be the correct answer. Hope you got that. Next is question number 27. In a triangle ABC, if A and B, C, they are in arithmetic progression and A ratio C is 1:2 and B is this, then you have to find out the area of the triangle. So actually, okay, not a tough one. Let's go. So you are given that ABC, they are in AP. So if they are in AP, that means 2B is equal to A plus C. Also, you know one thing, that A plus B plus C is equal to 180-degree angle sum property. So that means this was equal to A plus C is equal to 2B. So that means 2B plus B is equal to 180-degree, or 3B is equal to 180-degree, or B will be equal to 60-degree. Now, by sine rule, you have that sine A upon A is equal to sine B upon B is equal to sine C upon C. Right? So sine A upon A is equal to, sine B is sine 60-degree, and B you are given in the question. This is 4√3. This is equal to sine C upon C. Or writing it properly, you have sine A upon A is equal to sine C upon C is equal to sine 60-degree. This is √3/2 into 4 root this. So this is equal to 1/8. So you have sine A upon sine C is equal to A upon C, that is equal to 1/2, because in the question you are given A is to C is equal to 1:2. That means A upon C is equal to 1/2. Right, so that makes 2 sine A is equal to sine C, or 2 sine A sine C can be written as sine 120 minus A, right? Because you know A plus B plus C is equal to 120. B is given to be 60, so A plus C is equal to 180 minus 60, which is 120, and C is equal to 120 minus A. All right, so here you have this is 2 sine A. I'm opening sine A minus B. So this is equal to sine 120 cos A minus cos 120 into sine A degrees. Sine 120 is equal to √3/2 into cos A, and cos 120 is plus 1/2 sine A. This is 2 sine A. So I'm taking this on the left hand side. So you will have 3/2 sine A is equal to √3/2 cos A, dividing both sides by cos A. So you will get tangent A is equal to √3/2 into 2 upon 3. So you will have 1/√3 over here, which is for tangent of 30 degrees. So that means you got the A angle as 30-degree, right? So your C angle will be left, and that becomes 90-degree angle. Now you had, let's say this is equation, let's get back to this equation, which we just wrote over here. Let's say this is equation 1. So from equation 1, you have a sine A upon A is equal to 1/8. So sine of 30-degree into 8 is equal to A. So A into 1/2 is equal to A, that is equal to 4. So you got the value of A as 4, and what you had to find out in the question was the area of the triangle ABC. So let's go for the area of the triangle ABC. See, now this is a triangle in which C is your 90-degree, A is 30, and B is 60-degree. So area of this is B, this is C, and this is A. Area of triangle ABC is given by half into B into A. What was B? It was 4√3. A we just calculated, it is equal to 4. So you have 8√3 square units as the answer to the question. Okay. So here you have option C is the correct answer. Hope you understood this. Next is question number 28. Question number 28 is x minus 2 upon this expression is equal to a upon this plus b upon this, then what is the value for this expression? So you have 17x minus 2 upon 12x square minus x minus 20. This is equal to 17x minus 2. I'm splitting the middle term in the denominator. So you have 12x square minus 16x plus 15x minus 20. So that's 17x by 2 divided by, I'm taking 4x common from here. 4x, so this is 3x minus 4 plus 5x, 3x minus 4. So 4x plus 5, 3x minus 4. So next is question number. Question number 28, if 17x minus 2 upon this whole expression is equal to a upon ax plus 5 plus b upon 3x plus b, then a into capital A plus b into capital B is equal to. So here you have 17x minus 2 upon 12x squared minus x minus 20. I'm splitting the middle term, so this can be written as minus 16x plus 15x minus 20. So this is, I'm going to take 4 common, 4x common. So we have 3x minus 4 plus 5 common. So 3x minus 4 again. This is equal to 17x minus 2 upon 4x plus 5, 3x minus 4. Right? Because see, I have to see something which matches with this. So a upon, now this can be written with as 4x plus 5, 3x minus 4. This can be written as a upon 4x plus 5, b upon 3x minus 4. So let's solve it. You will get 17x minus 2 upon 4x plus 5, 3x minus 4 is equal to 4x plus 5, 3x minus 4, or a into 3x minus 4 plus b into 4x plus 5. Cancelling the denominators, you have 17x minus 2 is equal to 3ax minus 4a, 4bx plus 20, sorry, 5b. Okay, I'm not keeping the denominators. I have already cancelled them. So this will be 17x minus 2 is 3a plus 4b x plus minus 4a plus 5b. Equating the coefficients of x and the constant, you have 3a plus 4b is equal to 17 minus 4a plus 5b is equal to minus 2. Let's do one thing. I'm going to multiply this with the 4 and this with 3 and adding them. You have 12a plus 16b is equal to 68 and minus 12a plus 15b is equal to minus 6. They will cancel, and 31b is equal to 62, which will give me b is equal to 2. So minus 4a plus 5 into 2 is equal to minus 2, or you have 10 plus 2, 12 is equal to 4a, or a is equal to 3. I got the value of a as 3 and b as 2. Okay, so now let's get back. You had the equation as 17x minus 2 upon 3x minus 4, 4x plus 5 is equal to 3 upon 4x plus 5 plus 2 upon 3x minus 4. So in this question, you have a as 3 and b as 2. Capital small a is this 4 and small b is minus 4. Now to find in the question was a into a plus b into b. So you have 4 into 3 plus minus 4 into 2, or 12 minus 8, which is 4. So this is the answer to the question. All right, let's check with the options. 4 is option B, and you have option B as the correct answer. right? Next is 29th question. A, B, C, they are the three non-coplanar vectors. M and N are scalars such that A plus B is equal to MD minus C and B plus C is equal to NA minus D. Then what is the value for this expression? Okay. So you are given that A plus B is equal to MD minus C. Also, B plus C is equal to, wait, I'll write here. B plus C is equal to NA minus D, right? Vectors, I hope you're assuming like this is the vectors. So, right. So here you have A plus B plus C is equal to MD. And here you have B plus C plus D is equal to NA. Okay, or you can say D is equal to NA minus B minus C. Now put the value of D in this equation, number 1. So you have A plus B plus C is equal to M into NA minus B minus C. So this will be equal to A. So I'm taking this A over here. This will be 1 minus Mn plus B, 1 plus M plus C, 1 plus M is equal to 0. Now you have A, B, C. They are non-coplanar vectors, right? So 1 minus M into N is equal to 0, which gives you M, N is equal to 1. Okay. Okay. So also N is equal to 1 by M. Also, you have 1 plus M is equal to 0. That gives you M is equal to 1. M is equal to minus 1. So you had N is equal to 1 upon minus 1, which is equal to minus 1. So M is equal to N is equal to minus 1. Now from equation 1, what you will be having, you will have A plus B plus C is equal to minus D, or A plus B plus C plus D is equal to 0. Okay, now what you had to find out was this. Let's get back. Now 3A, 2B, 2C plus D. This can be written as 2A plus B plus C plus A plus B plus C plus D, right? So this is 0. You will be left with 2A plus B plus C plus 0. So this can be written as A plus B plus C plus A. This will be A only, right? So now from equation 2, okay, this will be A only. Sorry, this is A plus B plus C. So you had A plus C plus D is equal to 0. So this is equal to minus D. So that is equal to A minus D. This is the answer to the question. We have option A as the correct answer. Hope you got that. Next is question number 30. If 2I plus j minus k, and this is the first, second, and the third vector, they are the position factors of the 3 points A, B, and C, respectively. Then which of the following is true about ABC? It's right-angled, isosceles, collinear, or scalene triangle. Okay, so let's write them first of all. A is 2I plus j minus k. B is I minus 3j plus 5k, and C is minus 3I plus 4j plus 4k. Now let's see the side AB. AB will be given by minus I cap minus 4j cap plus 6k cap, because see, 1 minus 2 and 3 minus 1, minus 3 minus 1, this will be minus 4. 5 minus of minus 1 will be plus 6. This is AB. And BC will be given by similar way, 4I plus 7j minus k. Then you have CA vector. This will be given by 5I minus 3j minus 5k. Now, the magnitude of AB vector will be given by root of minus 1 square, minus 4 square, and 6 square, which will be root of 53. Okay, and the magnitude of VC vector will be given by root of -4 square, 7 square, and -1 square, which is this. And the magnitude of CA vector will be given by root of 5 square plus -3 square plus -5 square, which is the root of 59. Now, all the three, they are not equal in any of the ways, right? Also, if I'm adding any two of them, I will not get the third. Like if I'm adding all of them, I will not get the third side. So I'm not get like you don't have AB plus BC is equal to CA types things, right? You don't have anything like that. That means they are not collinear also. So the only possibilities is it is a scalene triangle. That makes option D to be the answer. Right? Hope you understood. Next is 31st question. Let L be the line which is passing through the point 6i plus j and perpendicular to this vector. Theta be the angle between L and pi. What is the value for sine theta? Okay, so you are having that L is the line that is passing through I minus 9j. Question number 31. Let L be the line passing through the points I minus 9k. There is one more point which is missing over here, and that is 7j plus k. Okay, I'm gonna write I minus 9k and 7j plus k. And the pi be the plane which is passing through the point 6i plus j and perpendicular to the vector I plus j plus k. Theta is the angle between L and pi. And what is the value for sine theta? Okay, so you are given that L is passing through these 2 points, right? And you are given that this pi is passing through 6i plus j, and they are perpendicular, and pi is passing through this and perpendicular to this vector. Okay, so let's see. And perpendicular to the vector I plus j plus k. So let's say this is somewhat the plane. If this is the plane, okay, so this is the normal vector. N is equal to I plus j plus k. And this is the point where it is perpendicular. So P is the point on this plane, 6i plus j. And this is the line L somewhere. And this is normal, right? Let's say this angle is theta. If this is normal, then this particular angle will be equal to 90 minus theta. This is your line L, right? So now you have cos 90 minus theta. This will be equal to dot product of n into L divided by their magnitudes. So n and L, first of all, you have to frame the equation for L. I don't have the equation for L. So L will be given in the vector form. L will be given by 0, because here I is 0, 0 minus 1 I plus 7 minus 0 j plus 1 minus of minus 9 k, which makes L the vector for L to be equal to minus I cap plus 7j plus 10 k. So I'm going to use this over here in this particular equation. N was equal to, I am going to write it over here, N was equal to I plus j plus k, and L is minus I plus 7j plus 10k. So product of both of them, you will have minus 1 plus 7 plus 10 whole divided by the root of n. First of all, the root of n will be equal to 1 square plus 1 square plus 1 square multiplied by the root of minus 1 square plus 7 square plus 10 square. So this is equal to 16 upon, you will solve, you will have this as root of 3 into root of 150, which will be root of 450. So, you have cos 90 minus theta is equal to 16 upon root of 450. Cos 90 minus theta is equal to sin 90 sin theta. And I will break it out. This will be 8 into 2, and 450 can be written as 15 into root 2. So this will be equal to 8 root 2 upon 15. This is the answer to the question. You have to find out the sine theta, 8 root 2 upon 15. We have option A as the correct answer. Hope you understood this. Let's move to the next question. Question number 32. If OA is given by this, OB is this, OC is this, are the position vectors of ABC points then a unit vector perpendicular to the plane containing ABC is? So, okay. Let's write down the three vectors first. You are having OA as 2I minus j plus k, and OB as 3I minus k, 2j plus 3k. So, you know, AB is equal to OB minus OA. So, this is equal to I plus j minus 2k. Also, BC is OC. I'm talking about the vectors, okay? So OC minus OB, which will be equal to minus 3I plus 2j plus 4k. Then the perpendicular vector, then the perpendicular vector is equal to AB cross BC, right? So that is given by IJK 1, 1 minus 2 minus 3, 2 and 4. So this will be equal to I 4 plus 4 minus J 4 minus 6 K 2 plus 3, or this is 8I plus 2J plus 5K. Then the unit vector. Now it's easy. Unit vector will be given by 8I 2J 5K divided by its magnitude, which is root of 8 square plus 2 square plus 5 square. So this is this plus 5k divided by 64 plus 4 plus 25, or you have 8i plus 2j plus 5k divided by root of 93. Okay, so this is option D. So this is the correct answer to the question. Hope you understood this. Next is question number 33. So it says let B be this vector, C is this, the other two vectors. A is a vector such that A plus B plus C is equal to 0. You have to find out magnitude of A cross B plus B cross C plus C cross A. Fine. So, right, you're having two things. You are having B vector and C vector. Also, A plus B plus C is equal to 0. So I hope like you consider this. Please note down these two vectors, B and C. I'm going to start from here. A plus B plus C is equal to 0. I'm going to write A as such. So A is equal to minus B minus C, right? So this will be minus 3I plus 2J minus K minus I plus J plus K. So this will be minus 4I plus 3J. That's it. This is your A vector. Now let's find out the cross product of AB, BC and CA. So first of all, AB is I, J, K. This is minus 4, 3, 0. And B was 3 minus 2, 1. And this is I, J, K, 3 minus 2, 1, 1 minus 1 minus 1. And the C is I, J, K. C is 1 minus 1 minus 1. And this was A is minus 430. Okay. So this becomes equal to 3i. On solving, this will give me 3i plus 4j minus k. On solving, this will give me 3i plus 4j minus k. And the last one on solving will give me 3i plus 4j minus k. So A cross B plus B cross C plus C cross A, all these are vectors. Addition of all of them and then their magnitude. Let's add all of them. You'll get 3 plus 3 plus 3, that is equal to 9i. And 4j, 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 that will be 12j. Minus k, minus k, minus k, this will be minus 3k. So the magnitude is given by 9 square, 12 square, plus minus 3 square. So this is 81, 144 plus 9, which will give me root of 234. So root 234, I don't have this in the options. Probably there's a misspell of it. This should be 234. So root 234, if that is option C, then this is your answer. Okay, let's move to the next question, number 34. It says if each of the observations x1, x2 till xn is increased or decreased by k, then where k is a positive number, then the variance of the data thus obtained will increases by k, do not change, is equal to k square or is equal to 2k. Let's see. See, the mean of the observations x1, x2, mean of x1, x2 till xn. Let's say this is given by x bar, and you know x bar, this is equal to summation of xi upon n, and variance square is given by 1 upon n summation of xi minus x bar square. So that means variation of the term x from its mean. Okay, now if each observation is increased or decreased, if each observation is increased or decreased by k. So now on the new observation, let's say that yi is equal to xi plus minus k, maybe increased or decreased. So new mean in this case will be 1 by n sigma yi, or this will be 1 by n summation xi plus minus k, right? So the new mean will be 1 by n summation xi plus 1 by n summation k, or the new mean will be equal to, this was already equal to x bar plus 1 by n into nk, right? The number of terms like k is happening. Okay, so this will be x bar plus minus k only. This is the new mean, right? Now, what will be the new variance? New variance, this dash is equal to 1 by n summation xi plus minus k minus x bar plus minus k whole square. So that is 1 by n summation xi. Wait, here is one more bracket. Yeah. So I'll rewrite it properly. So here's one more bracket, and this is equal to 1 by n summation xi plus minus k minus x bar minus plus k whole square, or this is 1 by n summation x, yeah, xi. So they will cancel out, right? Minus x bar whole square, which is nothing but the variance square itself. Therefore, you see both the variances are same. So this is equal to this. So that means variance will not change. Okay, so that makes option B to be the correct answer. Okay, hope you understood this. Let's move to the next question. Question number 35, if F be the sample space of the random experiment E, and P be the probability function defined by the power set mathematical PS of S, then which of the following is not satisfied by P? Okay, so you have P null is equal to 0, P e raised to power C, P e complement EC is the complementary event of E, then this is true. Or P e lies between 0 and 1 for all E belonging to the sample space S. And fourth, if E1 is a subset of E2, then probability that E2 will happen is less than equal to probability E1. Okay, so here you have S to be the sample space for the random experiment. So if I pick up the option 4, if you have that E1 is a subset of E2, then in that case, of course, the probability that E2 will be greater than, this will be greater than the probability of E1, event E1. So that means option D is incorrect, because if this is a subset, E1 is a subset of E2, then the probability of event to happen is greater than probability of event E1 to happen. So that means option B is the correct answer. Right? Next is question number 36. A and B simultaneously toss one coin each time. Each 50 times, wait, sorry, I'll read it again. If A and B simultaneously toss one coin each every time, each 50 times, then the probability of not getting tail on both the coins is, see, if the coin is tossed, then the probability of getting a tail is 1 by 2. So if two coins are tossed simultaneously, if two coins are tossed simultaneously, therefore the probability of getting both tails, see, that will be equal to 1 by 2 into 1 by 2, that is 1 by 4. So probability of not getting both the tails will be not getting both tails will be 1 minus 1 by 4, that will be equal to 3 by 4. Now since the coin is tossed 50 times, then the probability of not getting the tail on both the coins, if coin is tossed 50 times, then probability of not getting tail on both coins will be given by 3 by 4 raised to the power 50. Okay, so that makes option A to be the answer. Hope you understood this. Next is question number 37. A pair of dice is thrown, then the probability that either of the dice shows 2 when the sum is 6. Okay, see, the possibilities of getting the sum of 6, the pair of dice is thrown, probability that either of the dice shows 2 when their sum is 6. So total possibilities of getting sum as 6, these are 1 and 5, 2 and 4, 3, 3, 4, 2, and 5, 1. So there are 5 such occurrences. And the total possibility that either of the dice shows 2 total possibilities that either of the dice shows 2, it's only in this or this case. So how many there are? 2 ways. Okay, 2 possibilities or 2 occurrences are there. So required probability will be given by number of favorable cases upon the total cases, which is 2 by 5, and option C is the correct answer. Hope you understood. Next is question number 38. If A and B are any two events of the sample space, then the set chaotic description of the event, exactly one of the events A, comma B to occur is. See here, E, C denotes the complement of the event. All right. So which of the following event is, options is correct? See, first of all, you have this as the sample space and this is your A and B events. So this is your sample space. Now the first, this is your sample space, and if I draw A event, so this will be given by this and this. So A will be given by this whole thing. This is A, and this is your whole sample space, right? And B complement will be this will be your P complement because B will totally be ignored. Okay, this was your B event. This was B complement, and what is A intersection B complement? This will be equal to this thing only. So this is your A and this is your B and this is your sample space S. Okay. Now, similarly, A complement, let's find out A complement that is equal to so this is B and this is A. So this is A complement. This represents. So what do you have as A complement intersection B? They are the same. A complement intersections B. So this is the one A intersection complement. This is your A and B, and this is your sample space, right? So therefore, what you see is A intersection B complement in union A complement intersection B. This is nothing but this shaded portion plus this shaded portion, right? So hence A intersection B complement union A complement intersection B. Here exactly one of the events of A or B occur, right? So this is the answer to the question. Let's check with the options. You have C as the answer. Okay. Next is question number 39. So if the mean and variance of the binomial variable x are 2.4 and 1.44 respectively, then the parameters n and p are respectively which of these options? Okay. So as we know that mean is given by np, which is 2.4 in this question, and the variance is npq, which is equal to 1.44. So from these two both equations, you have a q as 1.44 divided by 2.4, which will be equal to 9 upon 15, or this will be 0.6. So you will have p as 1 minus 0.6, or this will be equal to this, or this will be equal to 6 upon 10 or 3 upon 5. Okay. Now, I got the value of P and Q. Let's find out N. You had NPQ as 1.44. So N into P was equal to 3 by 5. And sorry, P is equal to 2 by 5 and Q is equal to 3 by 5. This is 1.4. 4 upon 100. I'm going to write it correctly once again. And is equal to 144 upon 100 into 5 into 5 upon 2 into 3. So this will be cancelled 48, and this will be cancelled 24. This will be cancelled at 20. So 4 and here 6. So n is equal to 6. I got the values for n, p and q. Now let's check with the options, because you had to find out the parameters n and p respectively are. N came out to be 6 and p came out to 2 by 5. So you have option A as the correct answer. Hope you understood. Next is question number 40. If the Bernoulli trial is conducted n times, then which of the following is not suitable to use Poisson distribution? Each trial results in two mutually exclusive outcomes, namely success, failure. The number n of such trials is sufficiently large and the trials are independent of each other. The probability P of success in each trial is very large. See, we know that the Poisson distribution is the limiting form of binomial distribution when events occur independently. Poisson distribution is the limited form of binomial distribution when events occur independently. Then the number of trials is very large. Is very large as n will approach infinity, and probability of success is very small. Probability of success is small as p approaches 0, such that lambda is equal to np, it always remains finite. Okay, so each trial results in two mutually exclusive outcomes, namely success and failure. The number of such trials is sufficiently large. The trials are independent of each other, or the probability P of success in every trial is very large. This is not suitable. So we have option, this is 4. Option A is the correct answer, because this is incorrect. Okay. Next is question number 41. It says the locus of the point which is equidistant from this point and this line is which of these options? You have 4 options over here. Okay. The locus, let's read it once again. Locus of the point which is equidistant from this point and this line. Okay, so let that point be x1, y1. Let the point be x1, y1. So what you have is root of x1 minus 1 square, y1 minus 1 square. This is equal to, this distance is equal to distance of x1, y1 from this point. So this is given by x1 into 1 plus y1 into 1 plus 1 upon root of 1 square plus 1 square. Okay, so this will give me, yeah, so let's solve it first. Let's open it up. I'm squaring both sides and opening this one at the same time. So squaring both sides, I will get x1 square plus 1 plus minus 2x1, y1 square plus 1 minus 2y1 is equal to x1 plus y1 plus 1 upon root 2 square will be 2 itself. Now let's do the cross multiplication. 2x1 square plus 2y1 square minus 4x1 minus 4y1. I'm bringing these two terms on the LHS, minus x1 minus y1 plus 1 plus 1. So this will be plus 2 into 2, 4 minus 1 is equal to 0. Or this makes 2x1 square minus 4x minus 3x1. Question number 41, the locus of the point which is equidistant from this point and this line is. So let's say, let the point be x1, y1. right? Now you're given that the distance of that point, this point x1, y1 from this point and this line is equal. Therefore, according to the question, root of x1 minus 1 square, y1 minus 1 square is equal to modulus of x1 plus y1, because x1 into 1, x1, y1 into 1, y1 plus 1 plus root of 1 square plus 1 square is equal to. Now, let's do the cross multiplication. So you will have root of 2 into x1 minus x1 minus 1 whole square plus 2 y1 minus 1 whole square whole under the root is equal to x1 plus y1 plus 1. Now squaring both sides, you will have 2x1 minus 1 square, 2y1 minus 1 square is equal to x1 plus y1 plus 1 square. So open it up, you have 2x1 square plus 1 square into 2. This is 2 minus 2 into 2, 4 x1 plus you have 2y1 square plus 2 minus 4y1 is equal to x1 square plus y1 square plus 1 plus 2x1 y1, 2y1, 2x1. Okay. So on solving this, you will get x1 square, y1 square minus 2x1 y1, and here is 4x1 and here is 2x1. This will be minus 6x1, right? Minus 4 minus this, minus 6y1, and this is plus 2 minus 1. Yeah, so this will be plus 3. So let's rewrite it properly once. You have x1 square, y1 square minus 2x1, y1 minus, I'm taking common, 6x1 plus 6y1 plus 3 is equal to 0. This is the perfect square for x1 minus y1 square plus minus, I'm taking the 6 common, x1 plus y1 plus 3 is equal to 0. Hence, the locus of the point is I'm rewriting, this will be x minus y squared minus 6 into x plus y plus 3 is equal to 0. That makes option B to be the correct answer. Right? Next is 42nd question. If the y-intercept of the perpendicular bisector of the line segment joining PQ is minus 4, then the possible value of K is. See, first of all, let's make this line. This is the coordinate axis. Actually, I can't make it because I don't know whether K is positive or negative. So let's just make the point P, which is 1, 4, and here is the point Q, which is K, 3. I don't know what is K, like positive, negative, so I can't draw it on the axis. Now, you're given that the y-intercept of the perpendicular bisector of the line segment joining. First of all, join this PQ, right? This is minus 4. Now, let's find out the slope of this line. So, slope PQ will be given by, this will be minus 3 minus 4 upon K minus 1, or this is equal to minus 1 upon K minus 1, right? Let this L be the perpendicular bisector. Perpendicular bisector of the line segment joining this. So this L is the perpendicular bisector, which is perpendicularly bisecting the line at point M. Now M is the midpoint on PQ. Because it is a midpoint on PQ, so M will have the coordinates as K plus 1 upon 2, 7 plus 4 plus 3 upon 2, which is 7 by 2. I got the coordinates of M, I got the slope of PQ. Now, if slope of PQ is equal to minus 1 upon K minus 1, therefore, slope of PQ into slope of L is equal to minus 1. Slopes, product of the slopes of two perpendicular lines is equal to -1. So slope of L will be given by -1 divided by -1 upon k minus 1, which will be equal to k minus 1 only. This is the slope of L. Now, equation of general equation of a line with y-intercept is given by y is equal to mx plus c. So here c is equal to -4. You are given in the question that y-intercept is -4. You already given this in the question. And we calculated the slope just now, that is equal to k minus 1. So now this equation will be y is equal to k minus 1 into x minus 4. Or you have y is equal to x. Mm, yeah, I'll keep it here only. Okay, y is equal to k minus 1 into x. Now the point M lies on the line. Now point M lies on line L, right? Therefore, it will satisfy this point. What was the point M? It was equal to 1 plus k upon 2, 7 upon 2. So this is equal to 7 by 2 is equal to k minus 1. X is equal to k plus 1 upon 2 minus 4. Or 7 minus 2 plus 4 is equal to, this is k square minus 1 upon 2. This will be 15 upon 2 into 2 is equal to k square minus 1, or 16 is equal to k square, which will give me the k's value as plus minus 4. So this is it. We had to find out the k value, that is -4, because plus 4 is not available. So I will go with option C. Right. Next is question number 43. Students, before starting with this question, here is a quick reminder to visit our website www.examsnet.com. Here you will find out this and many more similar entrance exam question papers for your better preparation. You must download our app. The link is available in the description box for a better preparation of your exams. So let's go with question number 43 now. It says if a straight line L at a distance of 4 units from the origin makes positive intercepts on the coordinate axis, then the perpendicular drawn from the origin to this line makes an angle of 60 degree with the line x plus y is equal to 0, then the equation of the line L is. Okay, let's make it on the coordinate axis first. So here is your coordinate axis. So this is the line which is x plus y plus, x plus y is equal to 0. And this line is passing through the origin. So this is your origin. Let's say this is O. A straight line L at a distance of 4 units from the origin. So this is a distance of 4 units from the origin. There is a straight line. Let it be like this, because it is making positive intercepts on the coordinate axis. So that means this line has to be in the, like, pass through the first quadrant. And perpendicular drawn from the origin so that it makes an angle of 60 degree with this line. So that means this is 60 degree angle. Maybe it's not up to appropriate up to the drawing, but this is 60 degree. Then the equation of the line L is, so let's say this is the point P, XY, this is the point, this is the point A, and this is your x-axis, this is your line L, and this is x plus y is equal to 1. Hope you're clear with all the lines. Now, let's say this is theta 1, which is 60 degree, and this is theta. So now in the question, theta 1 is 60 degree, or this is equal to 120 degree, and the theta is 15 or 75 degree. Now, in the triangle OPA, in the triangle OPA, OP is equal to x cos theta plus y sin theta. So OP, that is 4, it's given in the question, x cos 75 plus y sin 75 degree. So what is sine of cos 75 and sin 75? This is 4 is equal to, this is root 3 minus 1 upon 2 root 2 x plus root 3 plus 1 upon 2 root 2 into y. So this is equal to, I'm doing the cross multiplication, root 3 minus 1 x root 3 minus 1 y is equal to 4 into 2, that's 8 root 2. Okay, so that's it. I wanted this equation, and this is option A. Sorry, this is option B. Right? Let's move to the next question. Hope you understood this one. Next is 44th question. If P and Q are the XY intercepts respectively on the line passing through the points this and this, then what is the value for A square upon P square plus B square upon Q square? So here, the equation of the line, general equation of the line, it's given by X upon P, Y upon Q is equal to 1. Put the points in the line. So these are the 2 points. This is the point. This is A cos alpha upon P, B sine alpha upon Q is equal to 1. Or you have A cos beta upon P plus B sine alpha upon Q is equal to 1. So let's say A upon P is equal to X and B upon Q is equal to Y. So you have X sine alpha plus Y sine alpha is equal to 1. So here you have X is equal to 1 minus Y sine alpha upon cos alpha. And also you have X cos beta plus Y sine beta is equal to 1. So I'm putting the value of X from here in this question, in this particular equation. So 1 minus sine alpha upon cos alpha into cos beta is plus Y sine beta is equal to 1. That makes cos beta minus Y sine alpha cos beta Y cos alpha sine beta is equal to cos alpha, or you have Y sine A minus alpha is equal to cos alpha minus cos beta, right? Because I'm using this, I'm taking the Y common. So this is cos A cos B minus sin A minus sin A sin B. Right. So now, yeah. So from here you will have Y is equal to cos beta minus, here was minus taken outside. Okay. So cos beta minus cos alpha divided by sin alpha minus beta. And you know this is equal to A upon P, B upon Q, sorry. Right? Similarly, X was equal to sine beta minus sine alpha upon sine alpha minus beta. That's equal to A upon P. So let's say this is equation, let's name the equation, number the equations. First of all, I'll start with, this is equation 1, equation 2. I'll say this is equation 3. And this two are equation 4 and 5. Now squaring and adding equations 4 and 5. Squaring and adding equation 4 and 5. You have A square plus B, A square upon P square plus B square upon Q square is equal to, let's take it bit here. Okay, now I'm squaring and adding from right from here itself. So this is equal to sine square alpha minus beta, and here will be okay, this square plus this square. So this will be sine square. I'm just writing it properly. So sine square alpha plus sine square beta minus 2 sine alpha sine beta plus cos square alpha plus cos square beta minus 2 cos alpha cos beta. Okay. So, you know, this and this, this and this will give me 2. 1 plus 1, 2. I'm taking minus outside. So minus 2 sine alpha cos sine alpha sine beta plus cos alpha cos beta whole divided by sine square alpha minus beta. Right? Okay, I'm going to open this one as well. Sine square alpha minus beta. So this will be sine square alpha minus beta. You can write it as 4 sine square alpha minus beta upon 2 cos square alpha minus beta upon 2. Right. So taking 2 common from here, you will have this as 2 minus, this is the formula for 2 cos alpha minus beta divided by 4 sine square alpha minus beta upon 2 cos square alpha minus beta upon 2. Hope it is clear till here. So I'm going to take 2 common from here, 1 minus cos alpha minus beta whole divided by 4 sine square alpha minus beta upon 2 cos square alpha minus beta upon 2, right? So know one thing, that 1 minus cos alpha, this can be written as 2 outside, this can be written as 2 sine square alpha minus beta upon 2 divided by 4 sine square alpha minus beta upon 2 cos square alpha minus beta upon 2. So this 4 and this will cancel, sine square will cancel, and when you have 1 upon cos square alpha minus beta upon 2, or you have this as secant square alpha minus beta upon 2. So that's it. You have option C as the answer. Right? Next is question number 45. If AD is not equal to 0 and two of the lines represented by AX, this is AX cube, A into X cube, AX cube, plus this whole thing, they are perpendicular then. Let's read it again. If AD is not equal to 0 and two lines represented by this are perpendicular, then which of the following is true? Let's write down the equation. You have AX cube plus 3AB x square y 3c xy square plus dy cube is equal to 0. Now, because it's a cubic polynomial, so it represents 3 straight lines. It represents 3 straight lines. So let their slopes be m1, m2, and m3 be their slopes. So you have a plus 3b into y upon x plus 3c y upon x square plus d y upon x cube is equal to 0. Here I'm dividing both sides by x cube. Dividing both sides by x cube, right? So this will have roots as m1, m2, and m3, right? So you have, the product of the roots. This is given by the coefficient of d, which is this. Yeah, this is given by m1 into m2 into m3. This is given by minus. Question number 5, if AD is not equal to 0 and the two of the lines represented by this equation are perpendicular. Here, this is AX cube. I'm reading it again. If AD is not equal to 0 and two of the lines represented by this equation are perpendicular, then which of the following is true? So let's write down. You have AX cube plus 3B x square y 3c xy square plus dy cube is equal to 0. Now this equation represents 3 straight lines. It's a cubic polynomial. This equation represents 3 straight lines. Let's say their slopes are m1, m2, and m3. This is their slopes. So now this equation can be rewritten as, I'm dividing both sides by a cube, dividing both sides by a cube. You have a plus 3b y upon x 3c y upon x square 3d, not 3d, sorry, it's just d y upon x cube is equal to 0. Now this has roots as m1, m2, and m3. So now this equation becomes a plus 3mb plus 3m squared, 3cm squared plus dm cube is equal to 0, or rewriting dm cube plus 3cm square plus 3bm plus a is equal to 0. So from here, the product of the three roots, which we already talked, this is m1, m2, and 3. So product of the three roots is given by minus a upon d, right? Also, you are given that two of the lines in the question, it is given two of the lines, they are perpendicular. So that means that those two lines will be 1 and 2. So m1 into m2 is equal to minus 1, because product of the slope of two perpendicular lines is equal to minus 1. So minus 1 into m3 is equal to minus a upon d, or m3 is equal to a upon d, right? So assuming this as equation 1, let's put this value in equation 1. Put this in equation 1, you will get a plus 3m3b 3c m3 square at d m3 cube is equal to 0. Or you have a plus 3 into a upon d into b 3c a upon d square plus d a upon d cube is equal to 0. Or 3a plus 3ab upon d 3c a square upon d square a cube upon d square is equal to 0. Let's take the d square as LCM. So ad square plus 3ab d 3ca square plus a cube is equal to 0. Taking a common, a square 3bd 3 ac plus here was d square I'm left with, right? This is equal to 0. So cancelling the a, you have a square plus 3ac plus 3bd plus d square is equal to 0. That makes option B to be the correct answer. Hope you got that. Let's move to the next question. Question number 46. The absolute value of the tangent of the difference of the angles made by these lines with the x-axis is, let's say m1 and the m2 be two tangents. So you have 4 minus 24. I'm writing this as 4 minus, wait. First of all, let's write down this equation. You have 4x squared minus 24xy plus 11y squared is equal to 0. Dividing both sides by x squared, you will have 4 minus 24y upon x plus 11y upon x squared is equal to 0. So here, this is m, so this can be written as 4 minus 24m, because this is the slope, plus this square is equal to 0. So 11m square minus 24m plus 4 is equal to 0. So this has two roots. This has two roots, which are m1 and m2. So now this equation will be, I'm splitting the middle term. This equation will be 11m square minus 22m minus 2m plus 4 is equal to 0. 11m m plus minus 2 minus 2 m minus 2 is equal to 0. So the 2 factor 11 minus 11m minus 2 m minus 2 is equal to 0. So m can have the value 2 by 11 or 2. Now difference of angles will be given by m1 minus m2 upon, see, these are the two values, like here m1 let's say is equal to 2 and m2 is equal to 2 by 11. So m1 minus m2 upon 1 plus m1 into m2 is equal to modulus of 2 minus 2 upon 11, 1 plus 2 into 2 upon 11, which is equal to 22 minus 2 upon 11 whole divided by 11 plus 4 upon 11. So 11 will cancel and you will have 20 upon 15 or 4 by 3. This is the answer to the question 4 by 3. Let's check. You have option C as the correct answer. Hope you got that. Let's move to the next question, number 47. If the extremities of the diagonal of the square are this and this, then the length of its side is. See, you are given the extremities of the side of the square. So if this is the square, this is the diagonal, you are given the two extremities as this and this. So let the length of the square be equal to A. Let side of square is equal to A. So the length of the diagonal is given by, A root 2. So what is the length of the diagonal from the given points? If I say this is point A, B, and C. So AC will be given by root of 2 minus 1 minus 3 plus 2 square. So this is equal to 1 square minus 1 square 2 square. So that is equal to root of 6. Now, according to the question, they both are equal. So according to the question, A root 2 is equal to root 6, which gives you A is equal to this, or side is equal to root 3. So you have option B as the answer. Hope you understood this. Next is question number 48. Coordinate planes and planes pi 1, pi 2, pi 3, which are respectively parallel to these YZ, ZX, and XY planes at the distances A, B, C, form a rectangle parallelepiped. D1 is the diagonal on the face XY plane, not passing through origin. D2 is diagonal to the pi 2, coterminous with the D1, and if none of the coordinates of the vertices of the parallelepiped are negative, and angle between D1 D2 is theta, then cos theta is equal to. So take a minute, read the statement again, and understand it thoroughly. So let's make the plane first. This is a 3D plane. So here is this thing, and let's start with this question 48. Coordinate planes and the planes pi 1, pi 2, pi 3, which are respectively parallel to YZ, ZX, XY planes at a distance ABC. From a rectangular parallelepiped, D1 is a diagonal on X1, XY plane, not passing through the origin. And D2 is the diagonal of the plane pi 2, coterminous with the D1. If none of the coordinates of the vertices of the parallelepiped are negative, and the angle between D1 and D2 is theta, then what is the value for cos theta? So I've already made this diagram to understand the problem clearly. So this is actually passing, this thing is passing through your z-axis. This is the z-axis, right? Three-dimensional plane this is. Now here the plane ABGC is the pi 1, plane EDCG is pi 2, and AGEF is pi 3 plane. GC is equal to AD is equal to OF is equal to AB is equal to C, and you have a DC is equal to GE is equal to AF OB. This is equal to A. Also, EF is equal to GA, CB, OD. That's equal to B. And see, D1 is the diagonal FG over here. So FG, it is something like this. So this FG is given by the square or root of square of AF square plus AG square, which is A square plus B square. Also, D2 is GD, which is root of GE square ED square, that is equal to root of A square plus C square. So if I consider the triangle DGF, so here is the triangle DGF. So this is your D1, which is given by root of A square plus B square. D2, which is, sorry, A square plus C square. Right. So these are D1 and D2. Let's go for finding of DF. This is given by root of ED square plus EF square, right? Which is this. So I got DF as well. Now by the cosine rule, by the cosine rule, you have DF square is equal to GD square plus GF square minus 2 GD GF cos of theta. This is equal to C square plus B square is equal to A square plus B square plus A square plus C square minus 2 root of A square plus B square root of A square plus C square into cos theta. Right? That means you have cos theta is equal to C square plus B square minus 2A square minus B square minus C square. Minus C square, whole thing divided by 2 root of A square plus B square into root of A square plus C square. So the numerator now will be equal to this, and this will cancel this, and this will cancel, and 2 and 2 numerator and denominator will also cancel. So you will be left with the minus here is also minus. I've taken this. So minus will be also will be cancelled. So this will be A square upon root of A square B plus B square A square plus C square. Now that makes option, let's check, A to be the answer. Hope you understood this. Let's move to the next question now. Question number 49. An equation of the plane parallel to this plane and which is 1 unit distance from the origin is. Okay, let's say let the equation of the plane of the given plane which is parallel to this plane is given by is equal to x minus 2y plus 2z plus k is equal to 0. And your given distance from the origin is 1 unit and distance from the origin is equal to 1 unit. So its distance from the origin will be given by 0 into 2, minus 2 into 0 plus 2 into 0 plus k whole divided by root of 1 square plus minus 2 square plus 2 square. This is equal to 1, the mod. So this will be k upon, this will be root of 9 is equal to 1. So you will have k upon 3 modulus is equal to 1, which means k is equal to plus minus 3. So the two values of k are plus minus 3. Now equation of plane will be x minus 2y plus 2z plus minus 3 is equal to 0. So that's it. Plus 3 is not available, but yes, I have minus 3 wala option. So you have option C as the correct answer. Hope you understood that. Let's move to the next question. Question number 50. A circle S touches y-axis at 0, 3 and makes an intercept of length 8 unit on x-axis. If the center C of the circle S lies in the second quadrant and the distance of C from this point is. So basically, I think you have to find out the center C. Then only you can find out the distance, right? So let's make the diagram first. Here it is. Okay, it's not proper, but still fine. It looks something like this. A circle touches the y-axis at 0, 3. So it touches the y-axis at 0, 3. I don't know how it looks like, but let the circle be like this. So it touches the y-axis at 0, 3. So here is the center of the circle. Makes an intercept of 8 units on x-axis. So, okay, fine. Intercept of 8 unit on the x-axis and the center C lies in the center second quadrant according to this. So let's find out C. This is, let's say, A and B point. This one. This is your x and the y-axis. And according to the given information, you have, let's say, AB, not let, you are given AB, this is making 8 units on the x-axis, so AB is equal to 8. And here, let's say this M is the midpoint of AB. So M is midpoint of AB. Therefore, AM will be equal to BM. That will be equal to 4 because it's dividing the AB in halves. So A will have the coordinates as if this is C, if I'm taking this C as minus H3, then this M will be same minus H comma 0. Okay, so what will the coordinates of A point? This will be minus H minus 4, right? Comma 0, and B will have the coordinates as minus H plus 4 comma 0. So the radius R will be given in this case. It will be given by CA. This is your radius and it is given by, you know, the coordinates. So it will be minus H minus 4 plus H whole square plus 3 minus 0 whole square. So this is equal to 16 because minus this will cancel. 16 plus 9. So this will be root of 25. That is equal to 5. So now equation of circle. This is x plus h plus y minus 3 square is equal to 5 square, or that's equal to 25. Now you're given that a point 0, 3 lies on it. Now this point lies on the circle. So this will be given by h square plus 3 minus 3, 0 square is equal to 25, or this is equal to 5 square. So you will have h as plus minus 5. You got the two values for h. So you are given that the center lies in the second quadrant. Center C lies in second quadrant. So h is gonna be negative. So what will be the coordinates of C? It will be minus 5 minus, not minus, minus 5 comma 3. Right, now you have to find out the distance from C to this point, minus 2 minus 1. So distance between C minus 5, 3 to minus 2 minus 1. This is given by root of minus 1 plus 1 square plus 3 minus minus plus 1 square. Here is 2. So you have 3 square, which is 9, 16 under the root, or 25, or you have 5. So this distance is 5 and you have option C as the answer. Hope you understood this. Let's move to the next question. Question number 51. If the equation of the circle with radius 3 units touches this circle externally at 3, 0 is given by this, then we have to find out 3g minus 4f plus c. See, there's a problem in the question itself. The given question says that this point actually lies on the circle. That's why they are touching these externally. These two circles, they are touching externally at this point. So if I fill this point 3 comma 0 in this equation, x square plus y square plus 6x minus 8y minus 11 is equal to 0. So you will have 3 square 0, 6 into 3, 8 into 0 minus 11 should be equal to 0. So 9 plus 18 minus 11, this is of course not equal to 0, right? So that means this equation itself, the question itself is wrong. There is some problem and doesn't have any solution. Hope you got that. Next is question number 52. This question says tangent L1, 3x minus 4y minus 8 is equal to 0, and the chord L2, this equation, are at a distance of 2 and root 2 units respectively from the center of the circle S. HK is the center of S. So if I'm assuming this is a circle S, this is the center C, which is having the coordinates as H and K. So according to the question, this distance is root 2 and this distance is 2. If I take it this as point P, so PC is equal to 2, and if I take this as Q, so CQ is equal to root 2. Okay, let's assume the Q has the coordinates as alpha and beta. So, okay, let's go. Now you have to, what given next? HK is the center of S such that H squared plus K squared is equal to 13. With the midpoint of the chord L2, this is chord L2, is equal to 0. Is alpha and beta. So this is Q is the midpoint. So that means this is equal to this. And the radius of the circle is R. So we are given the radius of the circle is R. You have to find out alpha plus beta plus R. Okay. So first of all, you have this equation. This is the equation of the chord, and this is the coordinates of the center. Now, according to the question, this distance is given to be as root 2. So root 2 is equal to modulus of H into 1 k into 1 minus 1 whole divided by root of 1 square plus 1 square. So this will be equal to root 2. So root 2 into root 2 whole square. This is equal to h plus k minus 1. Or you will have h plus k minus 1 is equal to plus minus 2. So that means h plus k can be equal to plus 2, or this can be equal to minus 2, minus 1. So here h plus k is equal to wait, this is equal to, and this is equal to over here. H plus k is equal to 2 plus 1, that is equal to 3. And here h plus k is equal to minus 2 plus 1, which is equal to minus 1. I got the two values for h plus k. So, yeah. So one more thing you are given, that h square plus k square is equal to 13. Right? So let's say this is equation 1. 2 and 3. Now from equation 2 and 3, 2 and 3, you have h square plus k can be written as a minus 1 minus h whole square is equal to 13. H square plus 1 plus h square plus 2h is equal to 13, or 2h square plus 2h minus 12 is equal to 0, or h square plus h minus 6 is equal to 0. So you will have the two factors as 3h minus 2h minus 6, h plus 3 minus 2h plus 3. So you will have h minus 2 and h minus 3. So h may have the two values as 2 and 3. Right? Ho gaya clear till here? Now from equation, I have to find k's value as well. From equation 2, you had h, what was that? H plus k was equal to minus 1. So if I'm taking h is equal to 2, so for h is equal to 2, k will be equal to minus 3, and for h is equal to 3, k will be equal to minus 4. Okay, so therefore h comma k can have 2 comma minus 3, or mm, or here was, sorry, plus 3. So it was supposed to be minus 3 over here. Okay. So this is minus 3 and the correspondingly here will be plus. So you will have a plus 2 over here. Okay. So this is the first value. H is 2 and K is minus 3. The second one is minus 3 comma 2. These are the two values for H and K. Now, if I take H comma K as minus 3 comma 2, like this one, then what you had to find out was alpha plus beta plus R. See, R is already 2. It's given. Okay. And alpha plus beta plus R. Now I know R is equal to 2, but I still am not aware about alpha and beta. Let's go to alpha and beta. Let's go to find out this alpha and beta. See, alpha beta lies on this line. So first thing that you have is alpha plus beta minus 1 is equal to 0. Also, you are given that this distance from the center is equal to root 2. So you had something like this. This was the center for which I'm taking minus 3 comma 2, and this distance, this is the line, this is the point alpha comma beta q. So that means alpha minus of minus 3 upon 1, because this was the line x plus y minus 1 is equal to 0, is equal to beta minus 2 upon 1 again, is equal to minus 3 into 1 plus 2 into 1 minus 1 whole divided by root of 1 square plus 1 square. So this makes, this gives me alpha plus 3 upon 1 is equal to, this is minus 2 upon root 2. Also beta minus 2 is equal to minus 2 root 2. Yeah. Question number 52, tangent L1, which is given by 3x minus 4y minus 8 is equal to 0. I have drawn it already over here. So this point P is the contact of the tangent with the circle S. And this L2, this is your chord at a distance of 2 and root 2 from the center. So this distance is 2 and this distance is root 2. Center HK of H such that h square plus k square is equal to 13. So you have h square plus k square is equal to 13 in the question. And if I take this point Q, you are given if the midpoint of the chord L2 is equal to 0 is alpha beta, let that point be Q, which is given by alpha beta, and radius of the circle is R. See clearly radius of the circle in this question is equal to 2. You have to find out alpha plus beta plus R. All right. So in the question you have CQ is equal to root 2 and the PC is equal to R is equal to 2. Right. Okay. So now, you know, this distance CQ is equal to root 2. I'm starting from here. So root 2 will be given by modulus of H plus K minus 1 root of n squared plus 1 square, which is equal to root 2 square. So that is equal to H plus K minus 1. So you will have H plus K minus 1 as plus minus 2. So that means this can have the value as plus 2 or this can have the value as minus 2. So from here H plus K is equal to 3 and from here H plus K is equal to minus 1. Okay. Okay. Now let's get back. Let's say this is equation 1. This is equation 2. And also we have h square plus k square is equal to 13. So you have h squared, k square can be written as minus 1 minus h. So h square, k square can be written as minus 1 minus h square is equal to 13. H square plus 1 plus h square plus 2h is equal to 13. 2h square plus 2h minus 12 is equal to 13. H square plus h plus minus 6 is equal to 0. The two factors will be h plus 3 and h minus 2. So you will have the two values of h as 2 and minus 3. See, when h is equal to 2, you will solve and you will find out from equation 2 itself, you will find out that k is equal to minus 3. And when h is equal to -3, you will find out k comes out to be 2. So here the point is 2, 3, and here the point is -3, 2. We got the 2 points, right? If I take the hk, if hk is taken as -3, 2, so that means here you got the center as -3, 2. Then what I have to find out is the value of alpha and beta. So it can be seen, it can be said that alpha minus of -3 upon 1 is equal to beta minus 2 upon 1 is equal to minus of -3 plus 2 minus 1 whole divided by 1 square plus 1 square. So you have alpha plus 3 is equal to 2 upon 2. Also beta minus 2 is equal to 2 upon 2. So this is alpha is equal to -2, and here the beta is equal to 3. Okay, you have to find out alpha plus beta plus r. So you have -2 plus 3 plus 2, which is equal to 3. So here you have option D is the correct answer. Hope you got that. Next is 53rd question. Polar of a point with respect to this circle, which is not a tangent and not a chord of contact, is. So you are given here the equation as x squared plus y squared minus 10x plus 12y minus 3 is equal to 0. This circle has the center, you know, it's minus g minus f. So this is 5 minus 6, and the radius will be given by g squared, which is 5 minus plus f squared minus c. So this is plus 3. You have here 25 plus 36 plus 3, which will be 8. Okay, so the radius for this one comes out to be 8. Okay, now if I pick up all the options one by one, let's pick up the first one. Now distance of the center, which is this, to this line, distance of center 5 comma minus 6 to 2x plus 3y plus 8 is equal to 0. This is given by 2 to 5, 3 minus 6 plus 8 whole divided by root of 4 plus 5. This is 0, right? Less than radius. So which is not a tangent and not a chord of the circle. So the diameter of circle, not the B part. Distance of center C, 5 minus 6 to the line 3x plus 4y plus 5 is equal to 0 is given by 15 minus 24 upon plus 5 upon 5, which is equal to 4 by 5. This is smaller than radius because the radius was 8. So this is chord to the circle. Next, C, distance of center 5 comma minus 6 to 5x minus 12y plus 7 is equal to 0. This is given by 25, 72 plus 7 whole divided by 13, that is equal to 8. That is your radius. So this is tangent of circle. So the D part, distance of center 5 comma minus 6 to 6x minus 8y plus 15 is equal to 0 is 30 plus 48 plus 15 divided by 10. This is equal to 93 upon 10. This is greater than the radius. Therefore, this is neither chord of contact nor tangent to the circle. Right. Therefore, the polar of the point with respect to the given circle, which is not a tangent and chord to, is this equation. That is option D. Hope you understood that. Let's move to the next question. Question number 54. The angle between the circles this and this is equal to 0 is pi by 4. Then which of the following is the value for C? Fine, so you have the two circles, x square plus y square, 2x minus 4y plus 1 is equal to 0, x square plus y square minus 4x minus 2y plus c is equal to 0. Here the center is given by minus 1 comma 2 and the center is given by 2 and 1. So the radius in this case is given by minus 1 square, which is 1 plus 4 minus 1. So this is equal to root of 4, that is equal to 2. And the radius 2, let's say this is R1, this is C1, and this is C2. R2 is given by 2 square 4, 1 square this minus C. So this is equal to root of 5 minus C. Right. Now, distance between both centers C1 minus 1 comma 2 and C2 2 comma 1 is D is equal to root of 2 plus 1, which is equal to 3 square, and 1 minus 2, which is minus 1 square. Okay, this makes it root of 10. So you have the distance D as root of 10. Also, we calculated R1 was equal to 2 and R2 was equal to root of 5 minus C. Now we know that the angle between the two circles is pi by 4. It's given. Angle between two circles is pi by 4. So cos theta, which is equal to cos pi by 4 in this question, is given by R1 square plus R2 square minus D square upon 2 R1 R2. Or you have 1 by root 2 is equal to 4 plus 5 minus C plus 10 multiplied by 2 into this. So you have 4 root 5 minus C is equal to root 2. I'm taking minus outside because this will be, sorry, this was minus 1 minus C. So I'm taking the minus outside. This is plus 1 plus C. I'm writing it properly once again. 4 into root of 5 minus C minus 2 into 1 plus C. Now squaring both sides. You will have 4, 5 minus C is equal to 2 into 1 plus C squared plus 2C, or 20 minus 4C is equal to 2 plus 2C squared plus 4C, or you have a 2C squared plus 4C plus 4C. And wait, I squared this and this should be this 4 multiply. It was also supposed to be multiplied. So this thing I have to redo. This is equal to 16, 5 minus C is equal to 2 plus 2C square plus 4C, or you have 80 minus 16C is equal to, I'm taking the 2 common from here. So 1 plus C square plus 2C. Yeah, and 2 will be divided on the LHS. You will have 40 minus 8C is equal to 1 plus C squared plus 2C, or you have C squared plus 2C plus 8C minus 39 is equal to 0. C square plus 10C minus 39 is equal to 0. So now the two numbers which should be divided, subtracted and added, they are C square 13C minus 3C minus 39 is equal to 0. So you have the two factors as C plus 13 and C minus 13. So that means C can have the value of 3 as 3 or minus 13. And you have option A as the answer because 3 or minus 13, you have option A as the answer. In fact, you have option B also as the answer. There are the two possible answers in the question. Right. Hope you understood this. Let's move to the next question. Question number 5. Let a focal chord 12x plus 5y minus 27 is equal to 0 of the parabola this intersect the parabola at the points P and P dash. If S is the focus of the parabola, then what is the value of 9SP plus SP dash? So you have the hyperbola as y square is equal to kx, or you have 4a is equal to k. That gives you a is equal to k by 4, right? Yeah. So in this case, the focus will be given by k by 4 comma 0. Now you're given in the question that this lies on this line 12x plus 5y minus 27 is equal to 0. So this gives you 12 into k by 4 plus 5 into 0 minus 27 is equal to 0. Or you have 3k minus 27 is equal to 0, which will give you k is equal to 9. So see, this parabola looks something like this. Right? This is the point S, 9 by 4 this, and this is the line 12x plus 5y minus 27 is equal to 0. Let this point be P and P dash. Right. So now we know that we know that 2a is equal to 2 into SP into SP dash upon SP plus SP dash. So what was A? We calculated A, it was given to us over here as k by 4. So you have a k, we calculated 2 into k by 4 is equal to SP dash 2 into SP dash. SP into SP dash upon SP plus SP dash. So K was equal to 9, right? First of all, this 2 and 2 will cancel. So you have 9 by 4 is equal to SP into SP dash upon SP plus SP dash. Or you have 9 SP plus SP dash is equal to 4 into SP multiply SP dash. So let's check. You have this 9 into SP plus SP dash is equal to 4SP into SP dash. Option D is the correct answer. Hope you understood. Next is question number 56. If E be an ellipse whose major axis is x-axis and minor is y-axis, if the distance of the point this on E from the foci are this and this, then the eccentricity of the ellipse E is equal to. Okay. So let's say this is the ellipse. You are given that major is x-axis and minor is y-axis. So the ellipse looks something like this. All right. So here is the axis. Now, at the point this, let's say this point lies here, 5 by 2, 2 root 3. On E, from the foci are this and this, 7 by 2 and this. So the two foci are, here is S and here is the second one. This point is AE comma 0 and this one is minus AE comma 0 S dash. So you have SP plus S dash P is equal to 2A, which is length of major axis. So you have 7 by 2 plus 13 by 2 is equal to 2A. Or you have A as 5. Therefore, the point S, which was this, and S dash, which was this, will now be S is equal to, and S dash is this. So you have SP will be, CP was, P had the coordinates as 5 upon 2, 2 root 3, right? So SP will have the coordinates as 5E minus 5 by 2 square, 0 minus 2 root 3 square. So SP, you know, it's given 7 by 2. So squaring it, you have 5. I'm opening the square, okay? So this will be 25E squared plus 25 upon 4 minus 25E, right? And yeah, this will be plus 4 into 3, that is equal to 12. Correct. So here you have 49 by 4 is minus 12 minus 25 by 4. I'm not going to get this minus 25. I will keep it on the right side. So this is equal to, I'm taking 25 common from here. This is e square minus e plus 1 by 4. So if I'm subtracting 49 by 4 and 12, I'm subtracting from it. You have this as 1 by 4 is equal to 25 into square minus e plus 1 by 4. So cross multiplication, you have 1 is equal to 100 e square minus e plus 1 by 4, or you have 100 e square minus 100 e plus 25 minus 1 is equal to 0. 100 e square minus 100 e plus 24 is equal to 0. Dividing both sides by 4, you will have 25 e square minus 25 e plus 6 is equal to 0. Applying the quadratic formula, which is this. So you will have 25 e will be equal to 25 plus minus 25 square, which is 625 minus 4 ac. So 4 into 25 into 6, this will be 600 upon 2a, which is 50. So 25 plus minus root of 25, this is equal to 5 upon 50. That means you will have the two values. Either it will be 30 upon 50 or it will be 20 upon 50. So that means either 3 by 5 or 2 by 5. These are the two values for E. And then now let's check. The E will have 2 by 5 is not there, but yes, we have 3 by 5. So option A stands to be the correct answer. Right, next is 57th question. P pi by 4, Q 3 pi by 4 are the 2 points on this hyperbola in the parametric form. Then the distance between P and Q is. So you have here 4x square minus y square minus 8x minus 2y minus 13 is equal to 0. This can be written as 2x square minus 2 into 2x into 2 plus 4. I'm separating this one. Minus y square plus 2y plus 1 is equal to 16. So this is a perfect square for 2x minus 2 square minus y minus 1 square is equal to 16. Dividing both sides by 16, you have I'm taking 2 outside, so 2 square, this is 4. 4x minus 1 square upon 16 minus y minus 1 square upon 16 is equal to 1. Let's say this is some capital X upon 2 square minus y square, because this will cancel, okay? Y square upon 4 square is equal to 1. Okay, now where x is equal to x minus 1 and y is equal to y minus 1. Therefore, the point P is 1 plus 2 sec pi by 4, 4 tangent pi by 4. So this is, this will be equal to sec pi by 4. This is root 2 and this is 4 into 1. So you have the coordinates as 1 plus 2 root 2 comma 5. Now Q. Q will be equal to 1 plus 2 sec 3 pi by 4, 1 plus 4 tangent 3 pi by 4. So that is again equal to 3 pi by 4. So this will be minus 2 root 2 and this will be 1 plus 4 into minus 1. This will be equal to 1 minus 2 root 2 comma minus 3. So now it got the point P and Q. This is P from 1 and this is 2 from 1 and 2. PQ will be equal to root of 1 plus 2 root 2 minus 1 plus 2 root 2 square plus 5 plus 3 square. So you have, this will be 4 root 2, that means this will be 4 root 2 square, this will be 16 to 32 plus 8 square, which is equal to 64. So you have 96 over here. Okay, that is equal to 16 into 6, or you have 4 root 6. This is the answer to the question. 4 root 6, option A. This is the correct answer. Right? Next is 58th question. If a point 1, 1 and the origin lie in the same region with respect to this hyperbola where A is greater than 0, then the range of A is. Let's try and understand the hyperbola first. So here is your coordinate axis. Wait. This is your coordinate axis and this is your hyperbola, something like this, right? This is the origin. Now it says the point P11 and the origin in the same region with respect to this hyperbola. So this is the hyperbola x squared upon a squared minus y squared upon 1 is equal to 1. Here are your x's. Now, because origin and the point 1 comma 1, both points lie outside the parabola, hyperbola, sorry. Therefore, 1 upon a square minus 1 upon 1 minus 1 is, if you will solve, this is less than 0 because s of 1 comma 1, this is outside the parabola. So here you will have 1 upon a square is less than 2, which will give me a square is greater than 1 by 2. Okay, or a is greater than 1 by root 2, right? Because, you know, a is always positive. So a belongs to this thing. I'll take a positive value only. So 1 by root 2 comma infinity. Right. So that makes option A to be the answer. Right. Here was some point P11. Okay. Next is question number 59. Now we are starting with the limits and then we'll be following some integration questions. Now limit this whole expression is equal to -2, then the coefficient of x in the expansion of this is. So here you have limit x approaching 1 fourth root of x raised to power -3 plus a power 4 into this whole divided by x minus 1 is equal to -2. So you have limit x is approaching 1. This can be written as x raised to power -3 by 4, a into x raised to power 5 by 4 whole divided by x minus 1. This is equal to -2. Now let the this limit is, if I'm putting this limit is of, yeah, if I'm putting this, so this is 0.04. What do you have to do? You know this. I'm going to apply L'Hospital's rule. So let's go. If I'm applying L'Hospital's rule, limit x approaching 1 -3 by 4 into x raised to power -3 by 4 minus 1 plus a into 5 by 4 into x raised to power 5 by 4 minus 1 whole divided by 1 is equal to -2. So you have -3 by 4 plus this is 5 by 4a. I have put the limits x is approaching 1. So this is equal to -2. That makes 2a is equal to, no, sorry, this is not a, right? So, okay. So this is equal to 5 upon 4a is equal to -2 plus 3 by 4. So 5 by 4a is equal to -8 plus 3 by 4 or -5 by 4. That gives you a is equal to -1. So this expression, this thing, see this in the expansion of this, let's try and expand this. This can be written as x raised to power -3 by 4 minus x raised to power 5 by 4. was equal to -1 and I filled it over here. It was x raised to power 5 by 4, 4 raised to power 4. One more thing in the question, this is supposed to be 5. All right, now let's get back to the question. So here you have TR plus 1 is given by NCR into the first term raised to power R, second one raised to power N minus R. So here N is equal to 4. So this is 4CR, x raised to power minus 3 by 4 power R minus x raised to power 5 by 4 power 4 minus R, right? So expanding it further, you have 4CR into x raised to power minus 3 by 4R plus this will be, if I'm putting this, so this will be, this is x raised to power, like minus will be cancelled over here. So because this will be 5 by 4, 4 minus R, you have 4CR x raised to power minus 3 by 4 into x raised to power 5 minus 5 by 4R. So by the same powers will be added and you will have minus 3 by 4R minus 5 by 4R plus 5, which makes 4CR x raised to power of 5 minus 2R. Okay, let's put 5 minus 2R is equal to 1. So from here you will get R's value is equal to, this will be 2. You will get R's value as 2. So the coefficient of x in 4C2 is given by 4 factorial upon 2 factorial into 2 factorial, which is equal to 6. Right. So that is option A. This is the correct answer. Right. Hope you understood this. Let's move to the next question. Question number 60. Let t represents the greatest integer function not exceeding t and c is equal to 1 minus 2 e square if the function fx is equal to this when x is less than 0, this when x lies between 0 and 2, this when x is greater than 0. This is continuous at x is equal to 2. Then fx is discontinuous at which of the options? Right. Now in the question you are given that the function is continuous at x is equal to 2. That means I'm going to pick up this one first of all, a. So that means a e square. I'm putting x is equal to 2 plus 2 minus 2. This is equal to this function also, because if this fx is continuous at x is equal to 2, then these two functions will have the same value, right? So this is equal to e raised to power minus 2 greatest integer function minus c. Here you have ae square plus 0 is equal to, see, this is also 0 and you are given c is equal to this. So this is 0. We will have minus of this thing, or a e square is minus 1 plus 2e square, or you have a minus 2 e square is equal to, that is equal to, question number 6. This represents the greatest integer not exceeding t, and the c is given by 1 minus 2 e raised to power 2. If the function fx is defined by this when x is less than 0, this when x lies between 0 and 2, and this when x is greater than 2. This is continuous at x is equal to 2. Then you have to find out that fx is discontinuous at which, like x is equal to 1 only, 0 and 1, 0 only, or 0, 1 and 1 by 2. Okay. So let's go, let's start with it. So you are given in the function, the question, let's start with this. You are given that fx is continuous at x is equal to 2. So if it is continuous at x is equal to 2, then let's pick up this function first. You have a e power x plus x minus 2, greatest integer function, greatest integer x minus 2. Now this should be equal to this function, right? Because this is x is equal to 2. If the function is continuous at x is equal to 2, that means the value of these two functions should come out to be same. Okay. All right. So this should be equal to e raised to power minus x minus c. Now let's fill at x is equal to 2. These two values will be equal. So this will give me a into e raised to power 2 minus 2 is equal to e raised to power minus 2, greatest integer e raised to power minus 2 minus c. So this is equal to 0. Here was the plus. So you have a e square plus 0 is equal to 0 minus c. C is given by this. So this thing. So here you have a minus 2e square. I'm taking common like this. This is equal to minus 1. Or you have a is equal to minus 1 upon e square plus 2. I got the value of a. Now let's check at x is equal to 1. At x is equal to 1, the left hand limit is given by limit x approaching 1 minus. This is a because it lies between this range. So I'll pick up this function a into e power x plus this. Right. So what is the value of a? This was minus 1 upon e square plus 2 into e power x. I'm filling the value, okay, x approaching 1 minus, so I will not write e power x, I'll just write e over here. Okay, plus limit x approaching 1 minus x minus 2. Now you know that x lies between 0 and 1. Right? So that means x minus 2, I'm picking only this thing, x minus 2 will be equal to, will be less than 1, or the greatest integer function for this will be equal to, if I'm taking the greatest integer for minus 2, minus 1, this is minus 2. So you have from here, this will be equal to e minus 1 upon e square plus 2 minus is this, okay, multiplied by e minus 2. Okay, now this was your left hand limit, and let's go for the right hand limit. Limit x approaching 1 plus, you have a e power x, again the same thing, x minus 2. This and now again I have minus 1 upon e square minus 2. Is it minus 2 or plus 2? Wait, it was plus 2, sorry. Yeah, it was plus 2, so plus 2 into e power again 1 plus you have limit x approaching 1 plus x minus 2. Now again you know x is greater than 1 because it x lies between 0 and 1, so x is greater than 1. That means x minus 2 is greater than 1 minus 2, that is minus 1. Okay, and the greatest integer function for this is greater than, sorry, this is equal to minus 1 only. So now this becomes, this is minus 1 upon e square plus 2 into e minus 1. So you see the left, this was your right hand limit. See the left hand limit and the right hand limit, they do not match each other. Therefore, function is discontinuous at x is equal to 1. Therefore, we have option as the correct answer. Next is question number 61. We have a matrix problem. Fx is defined by this matrix. Then the limit x approaching 0, fx upon f minus x is. Basically, we have already fx. See, this is given over here. And I'll go for f minus x. This will be first thing. Okay, first thing I'll do, I'll find a determinant of fx. Right. So fx is the determinant of this matrix. This is given by, it will be 1 into x minus 3 into 8 x cube minus 32 minus 33 x square minus 27 into 2x minus 4. So upon solving this, I'll not solve this, I'll leave it as such only. And what about the f dash, sorry, f minus x? This matrix will be given by 1, 6 minus x, 36 plus x square, 0, 0 minus x minus 3, 2 minus x minus 4, 3x square minus 27, 8x square minus 32. Let's find out a determinant now also. So f dash x will be given by 1 into, I'm not writing 1, let it be minus x minus 3, 8x square. Yeah, minus 32 minus 3x square minus 27 into minus 2x minus 4. Now, limit x approaching 1, f of x divided by f of minus x. Now, I think you are clear that why I have not opened up, because now there will be certain cancellations. Let's go. So, this is limit x approaching 1. This is equal to, let's do the division now. Here you have x minus 3, 8x squared minus 32 minus 3x squared minus 27, 2x minus 4 divided by minus x. I'm taking minus outside. Okay, so here you have x plus 3, 8x squared minus 32 minus 3x squared minus 27, and here was again minus I've taken outside, and here will be 2x plus 4. Okay, right. Now let's fill in 1. X approaching 1, I will fill 1. So this will be equal to 1 minus 3 minus 2. 8 minus 32, this is minus 24, minus 3 minus 27, minus 24 again. And this is minus 2 divided by 4 minus outside 4 and minus 24 plus minus 24 into 6, right? So this makes 48 minus 48, right? I think that's it. And here you have 96 minus 4 and 144, right? So this is 0 for sure, right? That means you already got your answer. Option C is the correct answer. Hope you understood this. Next is question number 62. Fx is differentiable on R and f dash m is not equal to 0, where m belongs to R. Limit x approaches m, this whole expression is equal to fm. Then what is the value of m? Okay. So you're given that fx is differentiable and f dash m is not equal to 0. Let's write it down. You have limit x approaching m, x into fm minus m into fx divided by fx minus m plus f dash m is equal to fm, right? So I'm gonna see if I'm putting x approaching m, this will be 0. So this 0 upon 0 form. I'll apply L'Hospital's rule. So here you will have this will be limit x approaching m, fm minus m into f dash x plus f dash m is equal to fm, because denominator I'll be having 1 only. So this is fm minus m f dash m plus f dash m is equal to fm, or you have 1 minus m. I'm taking f dash m common. This is equal to 0. So you have, you're given that f dash m is not equal to 0 in the question, which means 1 minus m will be equal to 0. Or you have m is equal to 1, right? That's it. You got the value of m is equal to 1. Option C is the correct answer. Hope you understood this. Next is question number 63. If let fx be differentiable function such that f of 1 is equal to 2, f of 2 is equal to 6, f of x plus y is equal to fx plus kxy plus 4 by 3y squared for all xy belonging to real numbers, then fx is equal to. So you have here fx plus y is equal to fx plus kxy plus 4 by 3y squared. Now I will put x and y both equal to 1, right? Then if I'm putting x and y both equal to 1, so from here, f of 2 will be equal to f of 1 plus k into 1 into 1, that means k, plus 4 by 3, 1 square, that will be 1 only. So you are also given that f of 1 is equal to 2. Oh, sorry, f of 2 is equal to 6. So you have a 6 is equal to f of 1 is equal to 2. 2 plus k plus 4 upon 3. Solving this, you have k as 6 minus 2 minus 4 by 3, 18 minus 6 minus 4 upon 3, or you have 8 upon 3. This is the value for k. Since fx is differentiable, therefore f dash x is equal to limit h approaching 0 f of x plus h minus f of x divided by h, limit h approaching 0 f of x plus k x h plus 4 by 3 h square minus f of x upon h. So f dash x is equal to kx, right? When x is approaching 0. So first this and this will be cancelled. So yeah, how is this? Because I'm going to take h common from here, kx plus 4 by 3 h divided by h in the denominator, so they will cancel. Okay, so that's why fx is equal to kx, and we know f dash x is equal to 8 by 3. I'm filling the value of k as 8 by 3 x. So f x will be 4 by 3. I'm like integrating it. So it will be 4 by 3 x square plus c. Integrating both the sides. So let's put x is equal to 1 now. F of 1 will be equal to 4 by 3 into 1 plus c. You know f of 1 is equal to 2. So you have this 2 minus 4 by 3 is equal to c, or you have c as 2 by 3. So fx is equal to 4 by 3 x square plus 2 by 3. That makes option D to be the correct answer. Hope you understood. Next is question number 64. Fx is equal to this function when x is not equal to 0, and this is equal to 0 when x is equal to 0. Then at x is equal to 0, x, fx and fx respectively are differentiable and continuous. We have to find out all these things. So let's pick up the function and check. You are given the function like this thing when x is not equal to 0, and this at x is equal to 0. First of all, let's check for the continuity of the function. Checking continuity of the function at x is equal to 0. Left hand limit, that is f of 0 plus, this is limit h approaching 0, 5 into e raised to power 1 by h plus 2 upon 3 minus e raised to power 1 by h. Or you have limit h approaching 0, e power 1 by h, I have taken common, 5 plus 2 upon e power this, divided by, again I have taken this common, 3 upon e power 1 by h minus 1. So this is equal to 5 plus 2 upon infinity, 3 upon infinity minus 1, that is 5 plus 0, 0 minus 1, which is equal to minus 5. And what was the left hand limit? This is 0. Left hand limit is equal to 0 is not equal to the right hand limit. Sorry, this is the left hand limit, right? Yeah, left hand limit is not equal to the right hand limit because the left hand limit came out to be 0, and this was, sorry, I'm so sorry. Left hand limit came out to be minus 5, and you have this as x is equal to 0. There is no right hand limit given over here, sorry. X is equal to 0 is 0, right? So I'm gonna write it again. LHL, left hand limit, is equal to -1, and at x is equal to 0, f of 0 is equal to 0. So that means they do not match each other. So function is not continuous at function is not continuous at x is equal to 0. Since it is not continuous, so it is not differentiable as well. Then function is not differentiable at x is equal to 0 as well. That makes question number 64, let fx be equal to this function when x is not equal to 0 and this is equal to 0 when x is equal to 0. Then at x is equal to 0, x, fx and fx respectively are differentiable and continuous. You have to check for these things. So let's pick up the function first of all. Let's check for the continuity of the function first thing. Let's check for the continuity of fx at x is equal to 0. So you have limit, left hand limit f of 0 plus, this is equal to limit h approaching 0, 5 raised to power e 5 into e raised to power 1 by h plus 2 divided by 3 minus e raised to power 1 by h. So this is equal to limit h approaching 0, e raised to power 1 by h, I'm taking common, 5 plus 2 raised to power 2 upon e raised to power 1 by h divided by 3 upon e raised to power 1 by h minus 1. So here you have 5 plus 2 upon infinity, and this will be 3 upon infinity minus 1, which will give me 5 plus 0, 0 minus 1, or this is equal to minus 5. So you have your left hand limit is equal to -5 and your f of 0 was equal to 0, which do not match. That means fx is not differentiable. Oh, sorry, fx is not continuous at x is equal to 0. So if it is not continuous, then it is not differentiable as well. Right? It is not differentiable as well. That means, see, I have to check for this thing also, but there is no need because this, and this, they all are wrong. So I'm only left with option C. Okay. So to save your time, you can pick option C. No need to check for this thing. Hope you got that. Next is question number 65. The ordinates of the points on the curve y is equal to tan inverse sine root x, where x lies between 0 to 8 pi square, at which the tangent is parallel to the x-axis is. So you have the curve y is equal to tangent inverse sine of root x. Let's differentiate both sides with respect to x. So you have dy by dx is equal to 1 upon 1 plus sine square root x into the derivative of sine root x into a derivative of root x. So now you're given that this tangent is parallel to the x-axis. If it is given, tangent is parallel to x-axis. If this is parallel to x-axis, then you have dy by dx is equal to 0, or you have a cos root x upon 2 root x 1 plus sine square root x is equal to 0, or simply this is equal to 0. You are given that x lies between 0 and 8 pi square. So that means this thing, minus 2 root 2 or pi. This lies because, wait, this is equal to this. Wait, I'll re-explain this. Wait. So I'm taking the root on both sides. You will have root of x is less than equal to, here will be plus minus 8 root is 2 root 2 pi. So that means minus 2 root 2 pi is less than equal to x, root of x less than equal to 2 root 2 pi. So you simply have a root of x is equal to plus minus pi by 2, right? Question number 65, the ordinates of the point on the curve y is equal to tangent inverse sine root x, where x lies between 0 to 8 pi square, at which the tangent is parallel to the x-axis r. So the curve is y is equal to tangent inverse sine root x. Let's differentiate both sides with respect to x. We have dy by dx is equal to the derivative of tangent inverse is equal to 1 upon 1 plus sine square root x into derivative of sine root x is given by cos root x into derivative of root x is given by 1 upon 2 root x. Now you're given that the tangent is parallel to x-axis. Since tangent is parallel to x-axis, therefore dy by dx is equal to 0, slope is equal to 0. That makes a cos root x divided by 2 root x into 1 plus sine square root x is equal to 0. Or you simply have cos root x is equal to 0, right? No, in the question you are given that x lies between 0 to 8 pi square. So taking root on both the sides, you have this thing. Correct? So that means x root x lies between these two values, right? Or simply, here's the root x, or simply root x is equal to plus minus 2, right? Because you are given that root x is equal to 0. So that means root x is equal to plus minus 2. Therefore, ordinate, which is given by y, ordinate y is equal to tangent inverse sine of plus minus pi by 2, which is equal to plus minus, see this will be equal to plus minus 1. So tangent inverse plus minus 1 is equal to pi by 4. Okay, I'll write it properly once. So this is tangent inverse plus minus 1. So this is equal to plus minus pi by 4. Okay, so let's check with the options. You have option C as the correct answer. Hope you understood this. Next is question number 66. The function fx is equal to x squared plus 54 upon x is equal to what? Is increasing, decreasing, maximum, increasing. Okay, fine. Whatever the increasing, decreasing, or maximum type of things are there, we always find out the first derivative. Okay. You have fx is equal to x squared plus 54 by x. So let's find out its derivative. By 2x plus this will be minus 54 upon x square. So let's take the LCM. You have here 2x cube minus 54 upon x square, which is equal to 2x cube minus 27 upon x square. So see, for the increasing or decreasing, this should be equal to 0. This f dash x should be equal to 0. That means x cube minus 27 should be equal to 0. That gives me the value of x is equal to 3. Right, for sure. And you know one thing, x cannot be equal to 0 because x lies in the denominator. These two things are there. Therefore, this is increasing in 3 to infinity and decreasing in minus infinity to 0 union 0 to 3. Now from minus infinity to 0 to 0, 3, sign does not change. Therefore, neither maximum or minimum value in this range. All right, that makes option, it is decreasing and neither maximum or neither maximum or the minimum value. The correct answer. Next is question number 67. If a square minus 1 into x plus ay plus 3 minus a is equal to 0 is normal to this curve, then the interval in which a lies is, here the given interval is a square minus 1 into x plus ay plus 3 minus a is equal to 0. This is normal to this curve, and the second one is x, y is equal to 1. Here y is equal to 1 by x, or dy by dx is equal to minus 1 by x square. So let's differentiate here also on this this side also, differentiating both sides with respect to x. You have a square minus 1 plus a into dy by dx is equal to 0, or you have dy by dx is equal to minus a square minus 1 upon this, or this thing. Right. Now you're given that they are both perpendicular to each other. So that means their product is equal to minus 1. So you know the product of the slopes is equal to minus 1 if two lines are, or two things, they are perpendicular to each other. That makes minus 1 upon x square into 1 minus a square upon a is equal to minus 1. Right. Wait. Yeah. So I'll do one thing. I'll keep this minus sign intact. Okay. I'll keep it like a square minus 1 whole into the minus, right? So this will be equal to minus 1 by x square minus a square minus 1 upon a is equal to minus 1, or 1 by x square into a square minus 1 upon a is equal to minus 1. Now you know one thing, that this term is always positive because x square is always positive. So that means this term will be negative. A squared minus 1 will always be negative. This gives me a squared minus 1 will be negative, or you will have a is less than a square is less than 1, which means a square is less than plus minus 1. So that means you have the scope, you have the range as this will be minus infinity to minus 1, and union this will be 0 to 1. Right. So this is the range in which it is lying. So that makes option B to be the answer. Right. Next question number 68. Maximum value of x power 4, y power 4 when this is a square x power 4 plus b square y power 4 is equal to c power 6 is. So, okay, here you are. Let's write it down. You have first thing a square x power 4, b square y power 4 is equal to this. Or you can have y power 4 is equal to c power 6 minus a square x power 4 upon b square. So you have fx as x power 4, y power 4. So I'm putting this y power 4 in this equation now. You have here fx is equal to x power 4 multiplied c power 6 a square x power 4 divided by b square. So let's differentiate it now. You will have f dash x is equal to 1 upon b square. I'm keeping it outside, and this will be 4 x cube c power 6 minus 8x7 a square upon b power 6. So see, for the maximum or minimum, this will be equal to 0 because f dash x will be equal to 0. So you have 4x cubed c power 6 minus 8 a square x power 7 upon b square is equal to 0. This gives you x power 4. On solving, this will give you, okay, let's solve it. You have x power 3, say 6 minus a, 8a square x power 7 is equal to 0. Or I'm gonna take x cube common from here, or rather 4x cube common from here. So you will have a c6 minus 2a square x power 4 is equal to 0. So that means c power 6 minus 2a square x power 4 is equal to 0, or x power 4 is equal to c6 upon 2a square. Okay, so what does your y power 4 becomes? From here, y power 4 becomes, which was equal to c6 minus a square into c square upon 2a square whole divided by b square. That gives me y power 4 is equal to c power 6 upon 2b square. So the maximum value of x power 4, y power 4 is c6 upon 2a2, c6 upon 2b2, which means c12 upon 4 A square upon B square. So this is the answer to the question. Let's check. You have option B as the answer. Right? Hope you understood this. So let's move to the next question, number 69. Integral problem we are starting with. E raised to power integral of e raised to power sine x into this whole expression dx is equal to. Let's say this is equal to I. So I'm going to start solving from here. This is integral of e power 6. I'm opening, like, this will be x into cos x minus tangent x into secant x dx. Or this is equal to, I'm gonna open this, x into e raised to power sine x cos x dx minus integral of e raised to power sine x into tangent x secant x dx. Let's take this as the first and this as the second function. Here this as the first and this as the second function. Now integrating by parts. So after the integration by parts, you will have x into integral of e raised to power sine x cos x dx minus integral of derivative of x integral of e raised to power sine x cos x dx minus e raised to power sine x integral tangent x secant x dx plus integral dy dx of e raised to power sine x integral of tangent x into secant x dx. This one solving will give you x into e raised to power sin x minus this dx minus, not integral, e raised to power sin x to secant x plus integral e raised to power sin x cos x secant x dx. They will cancel. One more thing that will cancel is, okay, let's solve it further. So you have x into e raised to power sin x minus this will remain the same into secant x. Yeah, because so plus, yes, okay, nothing else, plus c. So I'm going to take now e raised to power sin x common, x minus secant x plus c. So this is the answer to the question. Let's check. You have A as the answer. Hope you got that. Next is question number 70. If f dash x is equal to a cos x plus b sin x and f dash 0 is equal to 0, f0 is equal to 3 and pi by 2 is equal to 5. What is the value of fx? Okay, now you are given the derivative and you have to somehow reach to fx. Okay, fine. So f dash x is equal to a cos x, b sin x. And you are given this is equal to 4. This is 3 and this is 5, right? So you have, this can be written as this f dash x can be written as dy by dx is equal to a cos x plus b sin x, or dy can be written as a cos x b sin x into dx. Now integrating both sides, integrating both sides, you will get like integral of dy is equal to integral of a cos x b sin x dx, or y is equal to a sin x b cos x plus c. Now, you know f of 0 is equal to 3 and f of pi by 2 is equal to 5. That makes this as y is equal to Sorry, not y, this will be 3. Three is equal to sine 0 will be 0 and cos 0 is 1. So this is minus b plus c, and pi by 2 is 5. So 5, sine pi by 2 is equal to 1. So this is a and this is 0. 5 is equal to a plus c. Let's say this is equation 1 and this is equation 2. Solving both of them. From here, you have 3 plus b is equal to c, and you have 5 minus a is equal to c. So you have 3 plus b is equal to 5 minus a, or you have a plus b is equal to 2. Let's say this is equation 3. Now, f dash 0 is equal to 4. You are given over here f dash 0 is equal to 4. That makes, what was f dash x? It was a cos x, b sine x. So 4 is equal to cos 0 is 1 and sine 0 is 0. So you have a is equal to 4. I'll fill this a in this equation. So a plus b was equal to 2. 4 plus b was equal to 2. You get b is equal to minus 2. I got the value of a and I got the value of a and b. Let's go to find out c. We received a is equal to 2. What was it? 4. So A was equal to 4, B came out to be minus 2, and you had C is equal to 5 minus A, so C is equal to 1. I got C is equal to 1. Got all the values. Now what we had to find out was fx, right? Or you had to find out y, which was A sine x minus B cos x plus c. So this makes 4 sine x plus 2 cos x plus 1. This is the equation. And let's check now. You have 2 cos x, 4 sine x plus 1. This is option A as the answer. Hope you understood. Next is 71st question. Integral fx dx is equal to this. Then integral of x raised to power 5 into fx cube is equal to. Okay. Here you are given this function. Let's write down integral of this is equal to this, right? Let's say x cube is equal to t. So you have 3x squared dx is equal to dt. And the integral of x power 5 fx cube dx will be equal to, see over here, this will be dx. Okay, wait. Dx can be written as, or you can say x squared dx can be written as 1 by 3 into dt. I'm taking this 1 by 3 outside now, and inside you will be left with t into, wait, I'll rewrite this thing. So first of all, this can be written as x cube into fx cube into x square into dx. Now I'm going to change this into dt thing. So now it will be 1 by 3 t into f of t dt. Solving using integration by parts, you have 1 by 3 t into integral of f of t dt minus integral of 1 into integral of f of t dt, this whole thing into dt. So this ft is equal to this minus integral of dt plus c, or 1 by 3. I'm going to write it, this function x cube minus x cube 3x square dx, or this is equal to this. Right? So this is the answer to the question, and you have option A as the answer. Hope you got this. Next is 72nd question. Integral of this whole expression is equal to fx plus ax plus b, and b belongs to the real numbers. Then which of the following is true for fx? So I'll start from the integration itself, right? Let's say integral of sine square alpha minus sine square x divided by cos x minus cos alpha dx. So you have fx, this is equal to fx plus this. Know one thing, that sine square x is 1 minus this. So I'm gonna write this now as integration of 1 minus cos square alpha minus 1 minus cos square x divided by this. So you have cos square, this will be equal to integral of cos square x minus cos square alpha upon cos x minus cos alpha into dx. This is a square minus b square form in the numerator. So you will have a cos x plus cos alpha cos x minus cos alpha whole thing cos x minus this dx. Now it's pretty easy, right? Cos x cos alpha dx. So you have integration of cos x, this is sine x, and cos alpha. Okay, this will be cos alpha into integration of 1, which will be cos alpha into x plus this. See, here this can be written as this. Cos alpha is a constant, so I'm writing it outside. Okay, so this can be written, right? That's it. We got our answer. So, okay, this is equal to fx plus ax plus b. So this is fx, this is ax, and this is b. Okay, so what was your fx? It is sine x, and a is cos alpha. That makes this option C to be the answer, right? Next is question number 73. If integration of x power 3m plus x power 2m plus x power m into this whole thing power 1 by m dx is equal to. So let's say this is equal to I, okay? And now this I can be written as integration x raised to power 3m plus 2m plus m. So this is 2 into x raised to power 2m, 3 into x raised to power m plus 6. I'm gonna do one thing. I'll multiply and divide by x power m. Okay. Yes, there is one more thing. This was 1 by m power, right, dx. Now this integration will be equal to, I'm taking this x raised to power m over here. So this will be x raised to power 3m, and this x raised to power m divided by 1 by m, this will be x only, and I'm gonna multiply over here, that over here. Question number 73, if integral of x raised to power 3m plus 2m plus x raised to power m into this whole thing dx is equal to. Fine, so I'll start solving it, and I'll do what? I'm gonna write the same x raised to power 3m, x raised to power 2m, x raised to power m multiplied by 2 into x raised to power 2m, 3 x raised to power m plus 6. This whole thing is now multiplied by x raised to power m upon x raised to power m. This whole was 1 upon m raised to power 1 upon m dm. Dx, right? So now I will take, I'll do what? Wait. I'm gonna take this x raised to power m upon m over here. So this can be written as x raised to power 3m, x raised to power 2m, x raised to power m divided by this x raised to power m upon this. I'm gonna take it over here, and I'm gonna keep this thing 2 into this, 3 into this, 6 into this into x raised to power m. whole tm dx, sorry, not tm, dx. Right, hope this step is clear. Now this is 1, so this can be written as, this is x raised to power 1, and I will take it on the numerator. So this will be integration of x raised to power 3m minus 1, x raised to power 2m minus 1, x raised to power m minus 1. This whole thing multiplied by 2 into this, yeah. So m will be added, so it will be 2m plus m, this is 3m, this is 2m, and 6m. 6 raised, sorry, 6 into x raised to power m whole 1 by m dx. Right. Now let's put this thing, put 2x3m, 3x2m, 6xm is equal to t. Let's differentiate both sides. So you have 6m x raised to power 3m minus 1 plus 6m x raised to power 2m minus 1, 6m x raised to power m minus 1 dx is equal to dt. Right? Yeah. So let's take the 6 common from here. 6m common actually. X 3m minus 1, x 2m minus 1, x m n minus 1 dx is equal to dt. Or you have this is equal, dx is equal to 1 by 6m into dt. Let's say this is your equation 1. So let's put this in equation 1. What does your equation 1 become? Now this is integral of that was 1 by 6m into dt. dt will come later. 1 by 6m into t into dt, right? So I'll take 1 by 6m t raised to power 1 by m. So 1 by 6m will be taken outside, t raised to power 1 by m into dt. This will be equal to 1 by 6m into t raised to power 1 by m plus 1 divided by 1 by m plus 1 plus c. So this integration now is equal to 1 by 6m, and integral of no, we have solved integral 1 by m plus 1. This is divided by, like, m will go in the numerator, 1 plus m. This will cancel. So you have 1 by 6m plus 1 into t power 1 by m plus 1. Okay. Yes. So now let's fill the value of t. That's all we are left with. So this is 1 by 6 into m plus 1 raised to power. This was 2 into x raised to power 3m, 3 into x raised to power 2m plus 6x raised to power m whole raised to power 1 by m plus 1 plus c. So this is the answer to the question. Let's check. You have, yeah, m plus 1 upon m. This is same as 1 by m plus 1. So here you have option A as the answer. Right. Hope you understood. Next, let's move to the next question now. Question number 74. If a belongs to z plus, that is positive integers, and x is the greatest integer, not more than x, then now the value of this integral is equal to 127. What is the value for a now? Fine, you are given that a belongs to positive integers, and also you are given that integration 0 to a 2 raised to power greatest integer x dx is equal to 127. Now this thing can be written as 0 to 1, 2 raised to power 0 dx, 1 to 2, 2 raised to power 1 dx, 2 to 3, 2 raised to power 2 dx, so on till a minus 1 to a 2 raised to power a minus 1 into dx. So this becomes, yeah, so that was equal to 127. This becomes 127 is equal to 2 raised to power 0 into x 0 to 1, 2 raised to power 1, x 1 to 2, 2 raised to power 2, x 2 to 3, so on, 2 raised to power a minus 1, x a minus 1 to a. So 127 is equal to 2 raised to power 0, that is 1. And this is 1 minus 0, 2 raised to power 1, 2 minus 1, 2 raised to power 2, I'll keep it, 3 minus 2. So on, 2 raised to power a minus 1, a minus a plus 1. So a minus a plus 1, yes. So 127 is equal to 1 plus 2 plus 2 raised to power 2 plus 2 raised to power 3, so on till 2 raised to power a minus 1. Now this, you see, this is a GP. This is forming a GP series, geometric progression series, having first term as 1 and common ratio as 2. So that makes 127 is a finite series, so this will be 127. First term that is given by the sum is given by a into r raised to power n minus 1 upon r minus 1. Here the r is your common ratio and a is equal to 1. So this is 1 into 2 raised to power, what is that? The number of terms, see, this is 1, 2, this will be a minus 1 plus 1. Okay, so this will be 2 raised to power a minus 1 upon 2 minus 1. So you have 127 is equal to 2 raised to power a minus 1, or 128 is equal to 2 raised to power a. You have this 2, wait, 2, 4, this is 2 raised to power 7. Yeah, is equal to this. That makes a is equal to 7. So you have a is equal to 7. Option B is the correct answer. Hope you understood this. Next is 75th question, again an integral problem. So here you are given limits minus pi to pi by 2 sine x into sine square cos x dx is equal to, I'll put cos x is equal to k, derivative, so minus sine x dx is equal to dk, or sine x dx is equal to minus dk. So the limits will also change when x is approaching minus pi, k will approach 0. And when, wait, sorry, when x is approaching minus pi, k will approach minus 1. Yeah, because cos of minus pi, sorry, yeah, cos of minus pi is equal to minus 1. And when x is approaching pi by 2, of course, k will approach to 0. So limits will also change. Now this integration, this integral will be equal to, let's say this is equal to I. Integral is, limits will change from minus 1 to 0 minus sine square k into dk. That's equal to minus 1 to 0 minus of 1 minus cos 2k upon 2 into dk. So this is, I'm taking minus outside, minus 1 by 2 dk minus 1 to 0 plus 1 by 2 cos 2k dk. So this will give me minus 1 by 2 k, limits minus 1 to 0, plus sine 2k divided by 2 into 2. 2 into 2 from 2 from this 2k, so this will be 4. Limits minus 1 to 0 plus seed constant. Okay, so this is equal to minus 1 by 2, minus of minus 1, this will be 1 plus 1 by 4, and this will be minus sine 2 plus c, minus 1 by 2 minus sine 2 upon 4, or you have minus, I'm taking this outside, 2 plus sine 2. This is the answer to the question, minus of 2 sine 2 upon 4. Here we have option D as the answer. Hope you understood this. Next, question number 76. Positive value of x satisfying this particular equation is. So Let's write down. You have x to 1, 1 minus d. Actually, this is very easy one. Now, let's find out the integral. This is, I can write it like 1 into dt minus t into dt. X1, x1 is equal to 1 by 2. Or this is t x1 minus t squared by 2. X1 is equal to 1 by 2, or you have 1 minus x minus 1 by 2 minus x square by 2 is equal to 1 by 2. This on like 1 minus 1 by 2, this will be 1 by 2 minus, I'm taking here minus x squared by 2 is equal to 1 by 2. These two things will cancel, and you have minus, I'm taking x outside. 1 minus x by 2 is equal to 0. So that means either x will be equal to 0, or x by 2 is equal to 1. That means x is equal to 2. So either x is equal to 0 or x is equal to 2. That these are the two options. 0 is not there, but we have 2. So that makes option D to be the answer. Hope you understood. Next is 77th question. The area in square units bounded by x is equal to 4, y is equal to minus 4, and y is equal to x. Again, like this is a very easy question for you, I think. So this is your axis. I know it's always tilted. It's never straight for me. Anyways, y is equal to x. So you have this line. Y is equal to x. And x is equal to 4. So 1, 2, 3, and 4. So this is the line x is equal to 4. Y is equal to minus 4. So minus 1, minus 2, minus 3, and minus 4. Basically, what you had to find out, area in square units bounded by x is equal to 4. This is the line x is equal to 4. Y is equal to minus 4. And y is equal to x's. So you have to find out this area. Right, this is the area what you need to find out. Now let's do some markings. This is the line x is equal to 4. This is your x-axis. This is the point 4, comma 0. Let's say, okay, let's say this is the point A. Okay, let's say this is the point B. This point is given by 4, comma minus 4. And this is the point C. And D, and say this is E. We have done all the markings now. You have to find out the required area. Easy. Let's go for the integration now. So integral 0 to 4 y dx plus minus 4 to 0 x into dy plus area. This is the point O. Area of square ODBE. Correct? See, 0 to 4 y dx. So 0 to 4, you have to find out this, the area bounded by this region. Right, the first one refers to this one. And minus 4 to 0 x into dy. So minus 4 to 0 x into dy. This is this shaded region, this one, plus area of this square. Okay, now it's easy. You have just, the framing was difficult, and once you have framed the perfect equation, now it's easy to go. So yeah, y dx, and y was equal to x in this case. So this will be integration of x dx 0 to 4 plus minus 1 to 0 y dy plus area is 4 units, 4 by 4 square. So here you have x squared by 2, 4, 0. This is y squared by 2 minus 4, 0 plus 16. So this is 16 by 2 plus this will be minus minus plus. So this is again 16 by 2 plus 16, which is equal to 32. Yes, right. So this is our area, 32 square units. And let's check. You have option B as the answer. Hope you understood this. Next is question number 78. Particular solution of the differential equation. This and y of 1 is equal to 0 represents. So you are given the equation as a 1 plus y square dx minus x into y dy is equal to 0. So here you have a dx minus xy dy upon 1 plus y square is equal to 0, or you have dx is equal to this. So you have dx upon x is equal to y into dy upon 1 plus y square. Let's do integration on both the sides. Integrating. Both sides you will have dx upon x is equal to y upon 1 plus y square dy. So this is log x is equal to 1 by 2 log of 1 by 1 plus y square plus 2 plus z, sorry. And now you're given that y1 is equal to 0, right? So y is equal to 0 when x is equal to 1. This means y is equal to 0 when x is equal to 1. So I'm using this equation now. This will be log of 1 is equal to 1 by 2 log 1 plus 0 plus c. So that simply means c is equal to 0, right? Because this is 0 and this is 0. So c comes out to be 0. Now what does this equation number 1 becomes? Now equation 1 becomes log x is equal to 1 by 2 log 1 plus y square, or x is equal to, see, this can be written as log root of 1 plus y square. So x is equal to root of 1 plus y square, or x square is equal to 1 plus y square, which gives you x square minus y square is equal to 1. That makes option, this is the equation of a hyperbola. So this is option D, right? Hope you understood this. Next is question number 79. C and D are arbitrary constants. Then y is equal to e power 2x. This whole expression is the general solution for which differential equation? So see, you are having the second derivative and the first derivative in all the options. Let's find out. You are having y is equal to e power 2x cos h root 2x d sine h root 2x. Let's differentiate both sides. So you have y dash is equal to first function into derivative of second plus second function derivative of first. So you are having, I'm defining derivative of this first. This will be 2 into e power 2x cos h root 2x. See, the c is missing. There is a correction. Here is c cos h. Okay. So here is c involved. C cos h root 2x plus d sine h root 2x plus second function into derivative of first. So e raised to power 2x into, this is c sine h root 2x plus d cos h root 2x into root 2, right? For both of these, I've taken common like root 2 from this and root 2 from this. When I'll be finding the derivative, I have already taken that common. Okay, so this y dash becomes 2y because this was already equal to y. So this is equal to 2y plus root 2 e power 2x c sine h root 2x d cos h root 2x, or second derivative y double dash is equal to 2y dash plus 2 root 2 y dash plus 2 root 2 into e power 2x c sine h root 2x d cos h root 2x plus 2 e power 2x c cos h root 2x d sin h root 2x. So y dash is equal to 2y dash plus taking 2 common, and again this was equal to your y, right? So this will be 2 into y dash minus 2 into, wait, see, look at this very carefully. Now, root 2 e raised to power 2x c sine, this whole thing can be written as y dash minus 2y, right? So I'm going to write that thing only. 2, like this 2 is going to write here. And this whole expression now will be written like this. Y dash minus 2y, y dash minus 2y. And this is equal to y itself. So this will be plus 2y. Hope you understood like what I have done over here. So y double dash is equal to, this will be 2y dash plus 2y dash minus 4y plus 2y, or this is equal to 4y dash minus 2y, right? This is, yeah. Okay, this is equal to this. I'm going to write it properly once again. So you have y double dash is equal to 4y dash minus 2y dash, or y double dash minus 4y dash plus 2y is equal to 0. So this is our final equation, the second differential equation. And let's check. This will match with option B. Okay. See, the question is very easy. Only the thing that confuses is always when we find out the derivative, cos changes into sine and sine changes back into cos with the sign changing, of course. Right. So y and y dash, they can very easily be merged in each other. You have to be very clear about this. And one thing, please note down, there is a correction in the question. Here is c cos h. Okay, note down that correction, and then you have to patiently solve the sum, because a very minor mistake at any point, like, you will lose the whole sum. Okay, hope you understood this. And then now let's move to the last question of the paper. Question number 80, which of the following is a homogeneous differential equation? What do you mean by the differential equation to be the homogeneous? See, differential equation, if I say dy by dx is equal to fxy, this is homogeneous if f of lambda x, lambda y is equal to lambda raised to power n fx y. Now, clearly, if you see the option C, you are given x square plus y square dx is equal to 2xy dy, or you have dy by dx is equal to x square plus y square upon 2xy. F, let's find out now f of lambda x, this is equal to f xy. If I put lambda x and lambda y over here, so this now will be equal to lambda x square lambda y square upon 2 lambda x lambda y, right? I'm now gonna take lambda square common, so lambda square x square plus y square upon 2 into lambda square into lambda into x into y. So they will cancel, right? This becomes equal to lambda raised to power 0 into x square plus y square upon 2xy, or this is equal to lambda power 0 f of x comma y. right? So this is of the homogeneous form, like we discussed over here. That means we have option C as the answer. Right. So students, with that, we have completed all the 80 questions of the paper. Hope you understood them well. And don't forget to visit our website, www.examsnet.com. Here you will find this and many more entrance exam question papers. You must download our app. The link is available in the description box for a better preparation of your exams. So students, keep shining, keep rising high. That's all for this paper, and very best of luck for your exams. Bye.